Cloud Compliance Program 2.1 Learning Objectives. After completing this chapter, learners will be able to explain the fundamental criteria for cloud compliance programs. 1. Build and design a cloud compliance program. 2. Describe legal and regulatory requirements and standards and security frameworks. 3. Define controls and identify technical and process controls. 4. Recall CSA certification, attestation, and validation. 5. 2.2 Overview. This chapter covers specific aspects of a cloud compliance program, mainly from the perspective of a cloud service customer, CSC. The cloud service provider, CSP, perspective is also covered to clarify what a CSC should expect from a CSP in terms of compliance support and inheritance. This chapter includes the following topics: fundamental criteria for designing a cloud compliance program, guidance on how to build a cloud compliance program, high-level framework, legal and regulatory requirements and standards, organizational requirements, control objectives control and process standards, technical and process controls, cloud-specific security control frameworks, cloud security certification and attestation. 2.3 Fundamental criteria for cloud compliance programs. This section presents the fundamental criteria for a cloud compliance program. 2.3.1 CSP and organizational system considerations. The objective of a cloud compliance program is to ensure that all aspects of cloud adoption in an organization adhere to the requirements for which it is accountable. Enterprise risk management, governance policies, information security, and data privacy are among the key components that drive decisions concerning the measures that the organization puts in place. Compliance ultimately aims to validate that these measures are appropriately designed, implemented, and operated as intended. Designing a cloud compliance program requires a complete understanding and documentation of the cloud ecosystem of the organization. Some cloud ecosystem elements include current inventory of all cloud services, CSPs of services and delivery, and a responsibility matrix for all elements. The organization needs to determine its risk appetite prior to making any agreements with CSPs, because outsourcing of responsibilities to a provider may accompany an increased degree of shared responsibilities, including potential new risk to which the organization was 106. Certificate of Cloud Auditing Knowledge Study Guide, copyright 2021, Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 106. Not exposed before outsourcing. Maintaining an effective enterprise risk management program that syncs with the cloud service portfolio helps to prevent any surprises. Other elements to determine during the design stage include establishing the systems that are critical to the organization and to the product or service it provides. Gaining this business understanding can involve several process capture sessions to examine how the business units currently operate. It is important to document and maintain this information to ensure that the organization is aware of any gaps between the inherent and residual risk that exceed the organization risk appetite. These gaps may require special monitoring until fully remediated or accepted. The nature and scope of the organization determine what is to be evaluated. This is especially important for organizations with business units that operate in various industries. Although all business units report to one parent or holding company, each industry can be subject to different regulations, laws, or additional requirements that need to be met. Identifying and inventorying everything for which the organization is accountable strengthens the compliance program. Hence, as the organization compliance requirements increase in complexity, it is very important to align the governance model for the cloud compliance program to deal with the related complexities. 2.3.2 Geographic and organizational structure considerations from the cloud user's perspective. Geographical considerations are also important. Example requirements for organizations in the United States are different from those for organizations in Europe. The nature of cloud services is that data often reside in multiple data centers in different locations for redundancy purposes. There are many laws affecting data storage and processing. These laws may require the cloud user to apply specific measures or controls to keep data secure for data privacy purposes. The choice of CSP determines the jurisdiction where data are stored. Depending on how the CSP organizes its infrastructure, the laws of several countries may apply. These considerations and variations of risk and compliance need to be built into the enterprise risk program. Specifically, relevant sovereignty risk needs to be included in the contract terms or conditions and in service level agreements, SLAs. Another consideration is the audience of key stakeholders for the compliance program. The organization should answer the following questions: who are the project sponsors, and what are their internal requirements for a cloud solution? What is the organizational structure, and how will communications be shared? Is there a command and control structure that may call for a specific set of controls and reporting? If reports are to be more widely distributed, does there need to be a different set of controls and different moderating? There may be an independent division of the organization or a system that requires a specific level of compliance. By having strong documentation of all the environments that are under the scope of the compliance program, there is less room for error. Such documentation can include architecture diagrams, network flows, escalation processes, infrastructure builds, and role and responsibility models. The reporting model for the cloud compliance program needs to be congruent with the magnitude and complexity of the investment of the organization in cloud computing and the complexity of the entire ecosystem. The different cloud models may have different compliance program configurations. Understanding the boundaries of the systems and their position within the organization can aid in how to validate or test that the controls in place are working properly. Aspects of the compliance program may need to be adjusted because of gaps being identified. 107 Certificate of Cloud Auditing Knowledge Study Guide, copyright 2021, Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 107. Under the shared responsibility model, which is an essential building block of contracts with a CSP, a distinction exists between security controls for which the provider is responsible and controls that remain the responsibility of the organization consuming the cloud service. The cloud customer inherits certain controls from the CSP directly or through a third-party organization, such as a co-location vendor or IT services provider. Knowing what those controls are is essential to set up a compliance program, and later, for auditing it. Fundamentally, a compliance program determines who is responsible for what controls. Developing the methodology to test and validate the effectiveness of the operation and design of the controls put in place is critical, so the organization can rely on this methodology to monitor and report any drift or changes. The fundamental criteria of building a cloud compliance program are summarized in the mind map in Figure 2.1, and its components are further addressed in the next sections. 2.4 How to design a cloud compliance program. When designing a cloud compliance program, the organization should identify the key actors and requirements. Figure 2.1, taking into account the following perspectives: business/organization, cloud ecosystem, governance, risk. 2.4.1 Key actors. It is important to identify key stakeholders early in the design phase of the cloud compliance program. Stakeholders should include relevant decision makers, risk owners, and executives accountable for business processes or objectives that are cloud dependent. Key stakeholders should also include anyone responsible for assessing, measuring, or Figure 2.1 mind map for designing a cloud compliance program actors business/organization perspective governance perspective cloud perspective risk perspective 108 certificate of cloud auditing knowledge study guide copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 108. Reporting on cloud compliance program performance. The key actors are the individuals who determine how the organization approaches the cloud, decide the strategy, budget, timeline, priorities, requirements, and risk appetite, and decide how the technical implementation will be done. It is important to interview and consult the key actors during the compliance program design phase. Figure 2.2. Following are some of the most relevant questions to answer. Who owns the cloud strategy? Who owns the cloud policy? Who are the cloud service sponsors? Who are the cloud service portfolio owners? Who are the cloud service owners? Who are the data owners? Who manages the cloud service? Who are the control owners? Who are the service risk owners and managers? Who are the portfolio risk owners and managers? Who is responsible for service evaluation and approval? Who is in charge of compliance? Who is the program owner? Who builds the compliance rules? Who checks and monitors the compliance rules? Are there any cloud brokers? What does the RACI, responsible, accountable, consulted and informed, matrix for each cloud service look like? Who is responsible for what? Who is accountable for what? Who is consulted for what? Who is informed about what? Other individuals who should be consulted include, but are not limited to, internal auditors, information security, chief information officer, CIO/chief technology officer, CTO, human resources, HR, personnel, external auditors, chief privacy officers and legal teams. Identifying the individuals who can answer these questions drives the development of the compliance program. 109 Certificate of Cloud Auditing Knowledge Study Guide copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 109. Figure 2.2 Mind map for key actors in a cloud compliance program. Who owns the cloud strategy? Who owns the cloud policy? Who are the cloud service sponsors? Who are the cloud services owners? Who are the data owners? Who are the services risk owners? Who are the portfolio risk owners? Who is the program owner? Who builds the compliance rules? Who checks/monitors the compliance rules? Who manages the services? Are there any cloud brokers? Who is accountable for what? Who is responsible for what? Who is consulted, when and about what? Who is informed, when and about what? Who is responsible for the service evaluation and approval? Who are the service portfolio owners? Actors. Who is in charge of compliance? 110 Certificate of Cloud Auditing Knowledge Study Guide copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image 2.4.2 Business and Organizational Perspective. The Cloud Compliance Program needs to consider different points of view, balancing the perspective of the business with the cloud computing perspective and the governance and risk management perspectives. The business structure, strategy, and approach determine which actions are required in the compliance program, because the type of organization determines what is strategically and tactically relevant, what resources are available, and what constraints, limitations, and dependencies the business faces. In essence, the business structure, strategy, and approach guide decisions on what is allowed and what is desirable. In addition, the business and organizational requirements have a substantial impact on the governance, risk management, and cloud computing strategy and approach. Figure 2.3. Following are key questions to consider. What is the nature of the business? In which business sector does the organization operate? Is it a highly regulated sector, example banking and finance, or healthcare? Is the organization or the sector considered part of the National Critical Infrastructure Plan? Is the organization operating in a non-regulated sector? Where is the company headquarters located? The answer to this question is one of the most important variables to determine the applicable legal frameworks. Where are the company subsidiaries? Does the company have other branch offices or subsidiaries? Where are they located? What is the market geolocation? What markets are served by the company? What is the level of IT dependency? Is the company heavily dependent on information and communication technologies? Can the company operate in the case of failure of the IT services? What is the level of digitalization? Figure 2.3 Mind map for the different perspectives in a cloud compliance program. Nature of the business, market share/position, market geolocation, organization headquarters, organization subsidiaries, level of IT/digitization, business/organization perspective. 111 Certificate of Cloud Auditing Knowledge Study Guide copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Organization status quo and preparedness. Understanding the past of the organization helps the team or individual in charge of cloud compliance to realize the history behind the current state of the organization compliance. Some key points to consider are, what is the current state of internal expertise in terms of audit and preparedness? What does the existing compliance program look like? Has the company gone through any audit in the past? If so, are the lessons learned applied today? Is there a dedicated security program, internal or external, managing security decisions? If the organization is multinational, does the compliance program make accommodations for independent country requirements? How does the organization ensure that it maintains compliance with independent country requirements? Has the organization been charged or penalized for previous compliance or legal violations? Larger financial commitments that an organization makes in cloud computing can drastically impact the IT department. Many of the impacts have a direct effect on the IT risk profile. Ways that cloud adoption can potentially impact the IT department include establishing the need to take the following steps: redesign the organization, possible reduction of staff, reassess data governance requirements, amend relevant IT, cloud, security and privacy policies/standards, define skill and competency gaps, reassess tooling and product effectiveness, drive the use of cloud-native security tools and third-party management efforts, implement continuous monitoring, validate existing technical controls for their applicability. 2.4.3 Governance perspective. Cloud governance and cloud compliance are closely related. The mind map in Figure 2.4 provides key considerations from the governance perspective. 112 Certificate of Figure 2.4 Mind map of the governance perspective. Alignment with governance requirements, internal policies, business requirements, technical standards, governance perspective, relevant certifications/attestations, international standards, sector-specific standards, national standards, industry standards and best practices, compliance requirements, portability and interoperability, resilience requirements, security requirements, cost requirements, governance perspective, applicable laws and regulations. Where is the headquarters? In which countries does it operate? Which business sectors does it serve? Where are the data centers? To what countries are data transferred? What are the processing, location and transfer requirements? 113 Certificate of Cloud Auditing Knowledge Study Guide, Copyright 2021, Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. The team in charge of creating the Cloud Compliance Program should consider the following: alignment between the cloud requirements and the governance requirements. What are the business requirements and how do they map to the cloud strategy and approach? What are the budget constraints and the resources available? What compliance constraints and priorities has the board imposed? What are the security requirements? What are the resilience requirements? What are the privacy requirements? What are the interoperability and portability requirements? What are the exit strategies for key CSPs? Financial reporting, annual financial statement disclosure regarding IT and cloud risk, key business and environmental risk, internal policies. What are the policies for IT? What are the policies for information security and privacy? Does the organization have a dedicated cloud computing policy? What does the policy say, and how does it align with the security and privacy requirements? Applicable laws and regulations. Where is the company headquartered? In which countries does it operate? Which countries are served by the business of the organization? Which business sectors are served? Other key questions to ask include the following: where are the data centers located? What types and categories of data are collected, processed and stored? In which countries are data transferred? What are the data processing, residency, retention and transfer requirements? How does the selected CSP/cloud service impact compliance with applicable laws and regulations? Applicable or relevant technical standards for security, privacy, interoperability, and portability. What are the relevant international standards? What are the relevant national standards? What are the relevant sector-specific standards? What are the relevant industry best practices? Applicable or relevant international, national, and sector-specific certifications and attestations. What are the relevant certifications for interoperability and portability? What are the relevant certifications for security, privacy, interoperability, and portability? What are the relevant attestations for security, privacy, interoperability, and portability? 114 Certificate of Cloud Auditing Knowledge Study Guide, Copyright 2021, Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description. Image for page with label 114. 2.4.4 Cloud Perspective. Understanding the cloud computing context is a core challenge when designing and building a cloud compliance program, because it requires analyzing and understanding the approach of the organization from an IT and business perspective. Understanding the cloud computing context also means understanding the differences between legacy on-premises IT and cloud technologies in terms of compliance needs. A strong interconnection and interdependence exists between the decisions that an organization makes from the overall IT governance and risk perspective, and those from a cloud perspective. For example, the organization risk appetite and budget constraints have a substantial impact on how aggressive or conservative its cloud approach is, which type of cloud services it uses, and for which type of data and business applications. Similarly, cloud strategy determined by the organization impacts the existing governance approach and the way it manages risk. Differences in legacy and cloud compliance programs. The traditional risk management approach applies to cloud computing, but the tactics and implementation styles used for traditional IT versus cloud-based IT can be significantly different. Legacy compliance programs rely on systems with defined boundaries. With the introduction of cloud technologies, a major difference is the reliance on third parties for the delivery of technology resources, limiting the direct control and influence of the customer over the quality, availability, and reliability of the services that a third party provides. Moreover, the same physical limitations exist, to the extent that the CSP attains the various compliance requirements, and at best are supplemented by virtual abstractions represented by software and automation. Hence, the concept of the cloud compliance program becomes the only vehicle available to validate the performance of the many cloud providers that may be fulfilling the compliance and business needs of the organization. In a cloud or hybrid environment, the access network is public, the infrastructure is virtual, the perimeter is unknown and access can be gained from anywhere. The methods that an organization uses to access systems and data differ fundamentally in the cloud compared to legacy on-premises systems. The cloud, by nature, is a much more dynamic environment. Services are more likely to change, and they can scale up or down faster. Static compliance programs may not be sufficient to keep up with the rate of change with a cloud service. Therefore, the compliance program needs to align accordingly. With a legacy program, the organization has complete control and responsibility for the infrastructure and all requirements that keep it secure. It is important to note that moving to the cloud does not shift all risk onto the CSP. Responsibilities are shared, based on the CSP model, but accountability remains with the customer. Many organizations are now adopting applications that are multi-cloud in nature. These are applications built by one software as a service, SaaS, provider and hosted on the infrastructure of another provider. Designing for compliance in this cloud-to-cloud or multi-cloud environment is very different from designing compliance in a legacy environment. It introduces risk that is associated with supply chain visibility and validation. Other considerations include how the rapid and dynamic rate of change in the cloud environment affects the risk posture of the cloud user. This consideration might raise questions about whether the cloud customer needs to change controls. The organization should have ways to monitor for change in the CSP service and drive adjustments if necessary. Due to the nature of cloud services that are easily consumed from a menu of services, such monitoring requires appropriate accommodation in the operation of the risk management program, so that it becomes much more sophisticated and agile as new services and features are adopted or modified using control panels and portals with minimal review or advanced oversight. See Figure 2.5 for a mind map of the cloud perspective. 115 Certificate of Cloud. Figure 2.5 Mind map of the cloud perspective. IT context, enterprise context, cloud policy. Which enterprise services are allowed in the cloud? Which categories of data are allowed in the cloud? Which types of cloud services are allowed for which enterprise services? Departments/units using cloud operational requirements, security requirements, types of cloud service models used, SaaS, PaaS, IaaS, types of cloud deployment models used, percent of IT services in the cloud, number of cloud services, number of CSPs, DevOps approach, hybrid community, private public cloud perspective, 116 Certificate of Cloud Auditing Knowledge Study Guide, copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 116. Business context of cloud approach. The cloud business context defines the scope, objectives, goals, policies, and strategies of cloud adoption within an organization. Depending on its culture, the highest level of governance within the organization may define the cloud approach, example with board and executive approval, or cloud adoption may be introduced with minimal or no approval or knowledge by the appropriate governance function, i.e., shadow IT. In the first case, with board knowledge, the organization should have a clearly defined cloud policy, strategy, and roadmap. In the second case, the organization is likely to have an ad hoc, opportunistic, and tactical approach that lacks a defined cloud policy and strategy, clearly problematic from a risk management and compliance perspective. Establishing a comprehensive cloud policy is very important to organizations that are planning to make major investments in cloud technologies and platforms. When creating policies, they should take the following considerations into account: criteria for limiting services that may be moved to the cloud, example only non-critical services or services that require high availability and resilience; criteria for defining which data may be moved to the cloud and under what circumstances, example non-sensitive and confidential data, only public data, or all data; information security and privacy requirements specific to cloud services and deployments that are critical to defining the new business operational models, which deployment and delivery model is allowed for which type of data and services, example critical business services and HR applications can only be moved into a private cloud, or public cloud environments can only be used for non-regulated data; how to define roles and responsibilities for technical and non-technical personnel, including employees, contractors, and business partners that may be using embedded cloud platforms and technologies; acquisition of the requisite software tools and services to manage and maintain the various cloud services and platforms, since on-premises solutions will not be viable; updates to procurement policies to ensure that proper risk assessments, product assessments, and due diligence are applied to all cloud service acquisitions, including the creation of standard service level agreements and contract addendums or exhibits; empowerment of the cloud compliance program to review and approve all cloud services and cloud service providers; criteria for defining responsibilities for enforcement and potential consequences of non-compliance, an important consideration for developing any new policy. It is also important to consider who is using the cloud and to know the business, operational, and security requirements. Different business units and departments may have different business and security requirements. Consequently, they may be using cloud services for different purposes or may not be using the cloud. This can create governance tension within the organization and, consequently, impact the cloud compliance program. For example, the marketing team in a multinational company may be using a CSP that does not specify to which countries the data are transferred and stored. This can conflict with legal and privacy requirements if the organization is being held accountable for adhering to geographic regulations, such as the EU General Data Protection Regulation, GDPR. 117 Certificate of Cloud Auditing Knowledge Study. IT context. The IT infrastructure is the core variable to consider when designing a compliance program. The shape that the program takes depends on its configuration. The basics are defined by the mix of service deployment models, private, public, hybrid and community, and service delivery models, IaaS, PaaS, and SaaS. The typical scenario is a hybrid cloud model. The cloud customer integrates the public cloud services into its existing on-premises infrastructure or private cloud. From the delivery perspective, it is likely that the customer has one or two IaaS or PaaS providers and multiple, from 10 to thousands, SaaS providers. It is important to consider who is managing the IaaS and PaaS. Is it the cloud customer itself, or does it outsource this role to a managed CSP? If it is outsourced, then managing the subcontractors becomes a key consideration in the compliance program. The compliance program is also influenced by the level of maturity and pervasiveness of the cloud implementation, and whether the organization is adopting a cloud-native development approach. Important questions to consider are: in which phase of the cloud journey is the organization? Is it developing a business case, introducing cloud for non-critical services, or trying to understand the extent of the shadow IT issue, or does it already have several years of cloud experience? Is IT centralized within the organization? What is the ratio between the total number of IT services within an organization and the number of cloud services? Is the company mostly cloud-based or mostly on-premise? How many CSPs are used? What underpinning contracts are in place? What is the total number of cloud services used? Tens? Hundreds? Thousands? How is cloud service use monitored? Are there mechanisms in place to understand if a service that originally was contracted for one purpose is evolving over time? In general, it is paramount to monitor the cloud service during its entire life cycle to ensure that compliance requirements are enforced during the initial service evaluation, during the execution, and during its retirement. Particular attention should be given to what happens to the data after a service is terminated. Two variables that have dramatically changed the face of compliance in the last few years are DevOps and automation. For organizations that are embracing cloud-native development processes, the approach to auditing and compliance is rapidly evolving toward a more agile way to implement and enforce compliance requirements. The pace at which new services are delivered, features are added, and changes take place necessitates a new way to structure compliance. A new way also offers the possibility for a more effective approach to compliance based on automation. Compliance becomes embedded in the development pipeline according to the idea of compliance as code. See Chapter 8 for in-depth treatment of the topic of DevOps and continuous compliance. 2.4.5 Risk Perspective, Risk Appetite and Risk Assessment. Identifying and understanding the risk to an organization is the foundation of designing an effective compliance program. Section January 4, 10 addresses risk management, defining some cloud-specific risk and providing an overview of key components of a risk management approach, based on best practices from the European Union Cybersecurity Agency, ENISA. The focus of this section is to make the connection between the risk management approach and the cloud compliance program to understand how they influence each other. Figure 2.6. 118 Certificate of Cloud Auditing. Risk appetite and status quo. The risk appetite of an organization determines its risk management style. An organization that is a risk taker may be willing to accept more risk in the face of a higher return, example a shorter time to market for a certain service, or adoption of IaaS providers that do not provide the required security capabilities, or adoption of a SaaS service without a thorough security assessment. In contrast, a risk-averse organization minimizes its risk exposure to lower the probability of suffering a negative event, but at the cost of losing possible opportunities. A difference in the terms of risk appetite might also appear between sections, departments, and business lines of the same organization. For example, within financial services organizations, which are typically risk-averse, there are business guidelines for which time-to-market initiatives take priority over information security. The design of the compliance program reflects the trade-offs between risk and opportunities, which themselves determine the compliance risk that the organization is willing to take. Although the risk appetite defines the modus operandi, the organization status quo defines the position from which the cloud compliance program starts. Analyzing the status quo helps to determine the existing level of risk. The Figure 2.6 mind map for risk appetite and risk assessment. Risk status quo. Risk appetite. Risk assessment. Risk treatment and acceptance. What is the risk appetite of the organization? What are the current risk levels? What additional risk is connected with cloud services? What are the existing risk management practices? Cloud services risk evaluation. Threats, impact, vulnerabilities, interdependency, risk, correlated risk, cloud services portfolio, risk evaluation, risk perspective. 119 Certificate of Cloud Auditing Knowledge Study Guide, copyright 2021, Cloud Security Alliance and CHAP. Additional perceived and real risk connected to adopting a cloud service, and the existing mitigation strategies and practices. In general, if an organization already has an established and mature IT risk management and compliance program, the cloud component is likely to be an evolution of that, with all the existing pros and cons attached. The existence of a mature IT compliance program offers the cloud program know-how, culture and capabilities on which to build, but it may create some friction between approaches to auditing that may be substantially different, especially if the cloud team embraces cloud-native development approaches like DevOps. When adopting new technologies that have the potential to significantly impact business progress and competitiveness, the most important thing for the organization is to have the capability to fully comprehend the risk and potential outcomes associated with the technology decisions that it makes. Hence, the organization should introduce a cloud compliance program carefully and deliberately, with confidence that the business, IT and security functions have the competency, skill sets, and authority to effectively guide its cloud journey. Risk assessment methodologies in the world of information security work broadly, as follows. Identify the scope of the information system and its governance. 1. Identify assets, example intellectual property, customers, websites. 2. Identify threats to those assets, and threat agents, example hackers, disgruntled employees, competitors. 3. Identify vulnerabilities that threat agents may exploit to realize a threat. 4. Compute risk as the product of the likelihood of the realization of threats and the impact of their realization. 5. Evaluate the computed risk against the risk appetite so that the organization takes steps based on the 6. Acceptability criteria. The intent of completing a risk assessment is to determine potential threats and vulnerabilities, and their likelihood, and their impact should they occur. The output of this process helps to identify appropriate controls for reducing or eliminating risk, a topic in the next section. The results of the risk assessment process are a key component of designing the compliance program, because they inform the risk registry. 2.4.6 Risk perspective, risk treatment and acceptance. This section discusses risk treatment and acceptance approaches and how they influence the design of a compliance program. After an organization identifies and assesses risk, the organization needs to determine the measures to put in place to achieve an acceptable risk level. See Figure 2.7. That means identifying security and privacy control objectives, designing technical countermeasures, technical controls, tailored to the organization, and implementing and monitoring their performance. All of that is typically done with the support of tools. From the business standpoint, it is fundamental to achieve a clear understanding of due diligence responsibilities and liabilities. In the context of cybersecurity, due diligence refers to the process of identifying and remediating risks associated with third-party vendors. 120 Certificate of Cloud Auditing Knowledge Study Guide, copyright 2021, Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 120. Figure 2.7 Mind map of the risk perspective, risk status quo, risk appetite, risk assessment, risk treatment and acceptance, control objectives, organizational controls, physical controls, technical controls. Is the control able to satisfy the requirement? How is effectiveness measured? Are the SLAs in place? Are the controls designed for automation? What levels of assurance are the controls supposed to offer? Control design, control implementation in case of shared responsibility. Who is responsible for what? What is the level of maturity in the control implementation? Who within the organization is responsible for control implementation? Who between CSP and customer is responsible for the implementation? Who is responsible for control monitoring? Who is responsible for control auditing? How frequently are the controls monitored and audited? How is evidence collected? How is evidence stored? What is the chain of trust? Who is accountable for the correct implementation of the controls? Who can monitor a control's effectiveness? Who is liable if something goes wrong? Who can audit a control's effectiveness? What is the level of automation? How many actors are involved? Are the responsibilities clearly assigned, both contractually and at the technical level? Are the CSP and customer working together as a team? Are there SaaS providers involved? Is there a CASB involved? Control monitoring, risk management tools, due diligence, liability, risk perspective. 121 Certificate of Cloud Auditing Knowledge Study Guide, copyright 2021. Control objectives. There is an argument that compliance in the cloud environment is theoretically the same as compliance in the legacy IT context. They carry similar types of risk, and many of the same preventive and detective controls are applicable. The key differences are the rate of change, the access from anywhere that the cloud allows, and some variations in terminology. There are generally 3 types of controls: preventive, detective and corrective. Examples of each type of control are data encryption, preventive, monitoring, detective, incident response, corrective. These controls may need to adapt and evolve depending on changes in the threat landscape. The compliance team should answer these questions. Over a given period, how accurately does the compliance program reflect the latest threats to the business? Have threats led to any changes in the choice and deployment of controls? Additional details on control objectives are presented in later sections. Control specifications. Design with cloud services. The need to design controls into processes and services at the outset is vital, because these services are primarily accessible via the internet rather than behind a corporate network, and, therefore, the risk is greater. Control specifications design is the way that those business processes are designed. It considers the objective of the process, how the process achieves its result, and process inputs and outputs. It is the job of the architect and the engineer to identify the technology components that will either embed or deliver particular aspects of the business process and determine how to orchestrate them. This means determining how they all work together to deliver the required functionality to the required standard, example an approved list of technologies or vendors. This can come in the form of an architectural blueprint that defines how the architect and engineer put things together. When designing processes and services, a group is normally responsible for making key decisions about how that process or service is designed, and for considering the trade-offs between cost, time, convenience, security, and privacy. Several important questions to address include: is the control able to satisfy the requirements? How is effectiveness measured? Does the organization define service level objectives, SLOs, and service qualitative objectives, SQOs? What is the process for defining SLOs and SQOs? How do internal SQOs and SLOs map to the SLAs that the CSPs offer? Are the controls designed for manual implementation or for automation? How do cloud-native development approaches, i.e., DevOps, impact the control design process? What is the expected level of assurance that the control is supposed to provide? See the Defining Controls section in this chapter for additional details on controls. 122 Control implementation. After controls are designed to align with the organizational architecture and can satisfy the risk requirements, controls can be implemented. The most important factor to consider when implementing cloud-related controls is the shared responsibility model. Key questions to consider when designing the compliance program follow: who is responsible, the customer or the CSP? Is there a responsibility assignment, RACI, matrix to determine who is responsible, who is accountable, who is contributing and who should be informed? If the CSP is responsible, who within the organization should determine if additional compensating controls are required? Who should implement them? When considering shared responsibilities, the following questions help determine who does what, how many actors are involved. Are the responsibilities clearly assigned contractually and at the technical level? Are the CSP and the customer working together in a joint team? Are there SaaS providers involved? Are there cloud access security brokers, CASBs, involved? Are other security as a service, SecAS, providers involved? Lastly, the organization needs to determine the level of the maturity of the control implementation. It is helpful to answer the following questions: are the controls implemented on an ad hoc basis, with a lift and shift approach 311 and no automation in place? Are cloud-specific controls in place? Are there simple automation techniques in place? Is a cloud-native approach used across the organization? Are there guardrails in place? Is the system optimized and automation centralized? Control monitoring and compliance reporting. Risk management and compliance are not one-off exercises, but a process of continuous improvement that requires checking and monitoring of controls and reporting the results back to the key stakeholders. Some key questions to be addressed in the compliance program design phase follow: who is responsible for the control monitoring? What extra activities does the organization undertake for cloud computing compared to on-premise? What changed after the organization started using the cloud? What is the level of maturity of the monitoring process? Who is responsible for auditing? How frequently are the controls monitored and audited? How is evidence collected? How is evidence stored? What is the chain of trust? What are the differences between cloud and on-premise? 131 The lift and shift approach to cloud migration entails that workloads, applications, and data will migrate from existing on-premises infrastructure, to the cloud with minimal or no changes. 123 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and ISACA. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description: image for page with label 123. Reporting. Reporting. This method should capture what is being reported, example which metrics are used, to whom it is being reported, specific timelines and an indication of what the organization is doing with the data it handles to improve its environment and reduce its risk. Risk. Example compliance reporting questions follow: how will the organization measure the success of its compliance? With whom, stakeholder and business units, is the data shared? What is the frequency of the reporting? Applicable laws and regulations largely influence this variable. What is the process for putting lessons learned into action? Is the organization responding quickly enough to an incident to minimize the risk? Organization responding quickly. Tools. Depending on its size, complexity, budget, and maturity, an organization might choose to adopt tools to streamline and improve its risk management and compliance programs. With the cloud compliance and governance markets evolving, the organization must have some method for delineating compliance reporting. This method should capture what is being reported, example which metrics are used, to whom it is being reported, specific timelines and an indication of what the organization is doing with the data it handles to improve its environment and reduce its risk. Example compliance reporting questions follow: how will the organization measure the success of its compliance? With whom, stakeholder and business units, is the data shared? What is the frequency of the reporting? Applicable laws and regulations largely influence this variable. What is the process for putting lessons learned into action? Is the organization responding quickly enough to an incident to minimize the risk? Tools. Depending on its size, complexity, budget, and maturity, an organization might choose to adopt tools to streamline and improve its risk management and compliance programs. With the cloud compliance and governance markets evolving quickly, a selection of solutions have become available to address and report status more quickly and efficiently. Governance, risk and compliance, GRC, tooling, such as GRC tools or Cloud Access Security Broker, CASB, solutions take the manual efforts from managing spreadsheets and other compliance processes and automate them into work streams of day-to-day tasks. These solutions are either on-premises or cloud-based, and they enforce security policies between cloud service providers and consumers. It is essential to combine and link the requirements of the organization with the cloud-based resources. Having real-time, consistent tools that handle this risk and organizational enforcement may help ease the minds of those responsible for its security posture. Due diligence and liability. The need for due diligence is crucial for any organization and particularly for one that relies heavily on possibly untrusted third parties. Cloud computing is a business model that blurs the boundaries between customer and provider and introduces a complex supply chain involving several untrusted partners. Therefore, organizations should give additional emphasis to the due diligence approach when designing a compliance program. Following are fundamental questions to address. Does the organization have an accountability program? What does it look like? How is accountability for the correct implementation of the controls enforced? How is the internal auditing function organized? How is accountability for the service evaluation managed? How is accountability for the cloud service lifecycle managed? How is liability attributed? 2.5 How to build a cloud compliance program. This section explains how to build a cloud compliance program. 124 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2020. 2.5.1 Components of a cloud compliance program. A cloud compliance program consists of a set of recurring activities that an organization undertakes to assess its implementation of an information system management program against a compliance regulation or framework, high-level framework. The cloud compliance program must consider the high-level framework, the perspective of the organization and its risk management objectives. The compliance program includes the following: high-level framework, business and organizational perspective, types of audits authorized, and schedule or trigger events, enterprise policies and procedures, documented information security, activity review, risk management and risk assessment process, auditing and assessment tools, any mandatory audit-related training, education, and awareness, dedicated compliance team/personnel. When developing a cloud compliance program, the cloud customer must review the cloud services it deploys and determine how those services fit within its policies and procedures to prevent, detect, contain, and correct security violations. High-level framework. When building a compliance program, what specific frameworks should the organization consider? The following factors to consider relate to the nature of the business activities of the organization location, and that of its customers, which determine the applicable legal frameworks and industry standards, organization code of conduct and best practices, dynamics of the market of reference of the organization, tactical and strategic plans, existing compliance program and its level of maturity, or lack of one, risk program. One way to start the process of defining the high-level framework is to identify the key questions to ask, the relevant structures and units involved, and the key business stakeholders who should provide answers and make decisions. In other words, define the cloud compliance requirements and determine their interplay with the business strategy, goals, and other compliance requirements of the organization. The effectiveness of the process of understanding and mapping the key individuals who are responsible, accountable, and possibly liable within the decision-making process, who own the risk, and who possess the information and data that should drive the compliance goals determines the success or failure of the cloud compliance program. 125 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 125. After the organization identifies those key requirements and stakeholders, it may choose to build its compliance program using frameworks from established international information security standards, such as ISO/IEC 27001-322 and the NIST Cybersecurity Framework. 33.3 See Section 2.6 for additional details on relevant security standards. Types of audits. The organization must define the types of audits it will accommodate or support. Audit types include the following: governance and strategy audit. This type of audit evaluates the framework of the organization for defining requirements, performing risk assessments, monitoring controls, reporting adherence, and developing a strategic plan for the cloud. Configuration and activity monitoring. This includes logging, monitoring, scanning and alerting of a system, account, or environment. It can be achieved using real-time automated scripts or manual testing. Organizations continuously perform this type of audit as part of operations, helping them to implement continuous assurance and continuous compliance as described in sections that follow. Access review. This is the review of all user and service accounts, and permissions within established information system boundaries, including on-premises systems, cloud environments, and other applications. As a result of each review, unused or invalid access is disabled. Compliance and controls audits. This is the audit performed against technical, administrative, and physical controls, as defined in the organization policies and procedures. Typically, either the designated internal audit team or external audit firm performs IT or cloud audits following a potential trigger event. These events might include scheduled compliance audits, business associates requests or complaints, discovery of significant vulnerabilities or breaches. Policies and procedures. Policies are high-level statements that define the rules by which the organization staff must abide while they carry out their various responsibilities. Procedures provide step-by-step instructions for specific routine tasks and may even include a checklist or process steps to follow. Policies and procedures are usually written to document the high-level direction of an organization. They reference the relevant standards to follow and the processes and procedures necessary for implementation and operation. Policies should include actions to take when violations are detected, including personnel-related actions and reporting. Documented information security activity review. The information security activity review encompasses the review and analysis of security logs, events, and audit trails by the security team, with the assistance of automated systems and processes. The review should look for information security activities, such as the following: the system must be configured with correlation rules and policies to identify suspicious activity, vulnerabilities, and misconfigurations. Rules applicable to alerts and escalations are defined and implemented to notify the responsible staff. 232 ISO/IEC 27001:2013 Information Technology, Security Techniques, Information Security Management Systems, Requirements, October 2013, www.iso.org/standards/54534.html 333 National Institutes of Standards and Technology, Cybersecurity Framework, www.nist.gov/cyberframework 126 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. Incidents are documented and escalated to a risk management process and logged in the risk registry. The risk register. Risk assessment and risk management activities are documented in the risk register. This is a document or software that includes all the risk and threats identified during configuration and activity monitoring, access reviews, and compliance and controls audits. It is very important to build and maintain a risk register as a software platform or a document. It records all the risk captured by the security committee that has an impact on business processes, applications, and security. The risk register records the outcome of quarterly vulnerability assessments and remediation plans. For example, the subcomponents of a risk assessment and risk management plan follow: risk analysis plan, process to review and report audit findings, process to remediate controls deficiencies, risk register, auditing and assessment tools. The audit and compliance team may select and use assessment tools to detect vulnerabilities and intrusions. These tools may include the following: scanning tools and devices, password cracking utilities, network sniffers, security agents installed locally on servers and endpoints, vulnerability scanning software, passive and active intrusion detection systems, penetration testing tools. Audit-related training, education, and awareness. Some regulations require that the workforce receive specific training on a periodic basis, usually once a year. To comply with the mandate, an organization maintains a list of the regulation and the required training, and a record of workforce attendance and participation in the training program. Training exercises can help organizations prove that their employees were made aware of their responsibilities and applicable sanctions or corrective disciplinary actions, if the audit process detects a failure to comply with the requirements. Dedicated team/personnel assigned the job function/responsibility of security and compliance. The organization must assign a dedicated team or personnel to the job function of security and compliance to enforce the principle of segregation of duties. Segregation of duties can be achieved via a combination of assignment of roles and responsibilities to different personnel, and automated enforcement for software-defined processes. Such segregation of duties and related review and approval processes ensure checks and balances. When applicable, designated personnel, separate from the individuals who are performing the work, must provide reviews and approvals. 127 Certificate of Cloud Auditing Knowledge Study Guide. Copyright 2021. Cloud Security incidents are documented and escalated to a risk management process and logged in the risk registry. The risk register risk assessment and risk management activities are documented in the risk register. This is a document or software that includes all the risk and threats identified during configuration and activity monitoring, access reviews, and compliance and controls audits. It is very important to build and maintain a risk register as a software platform or a document. It records all the risk captured by the security committee that has an impact on business processes, applications and security. The risk register records the outcome of quarterly vulnerability assessments and remediation plans. For example, the subcomponents of a risk assessment and risk management plan follow: risk analysis plan, process to review and report audit findings, process to remediate controls deficiencies, risk register auditing and assessment tools. The audit and compliance team may select and use assessment tools to detect vulnerabilities and intrusions. These tools may include the following: scanning tools and devices, password cracking utilities, network sniffers, security agents installed locally on servers and endpoints, vulnerability scanning software, passive and active intrusion detection systems, penetration testing tools. Audit-related training, education, and awareness. Some regulations require that the workforce receive specific training on a periodic basis, usually once a year. To comply with the mandate, an organization maintains a list of the regulation and the required training, and a record of workforce attendance and participation in the training program. Training exercises can help organizations prove that their employees were made aware of their responsibilities and applicable sanctions or corrective disciplinary actions, if the audit process detects a failure to comply with the requirements. Dedicated team/personnel assigned the job function/responsibility of security and compliance. The organization must assign a dedicated team or personnel to the job function of security and compliance to enforce the principle of segregation of duties. Segregation of duties can be achieved via a combination of assignment of roles and responsibilities to different personnel, and automated enforcement for software-defined processes. Such segregation of duties and related review and approval processes ensure checks and balances. When applicable, designated personnel, separate from the individuals who are performing the work, must provide reviews and approvals. 127 Certificate of Cloud Auditing Knowledge Study Guide. Copyright 2021. Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Reporting through automated techniques that are less transparent and more difficult to validate. This is especially the case when the compliance actions and evidence of operation are in the cloud and not performed with on-premises solutions. This decrease in effectiveness in achieving enterprise-wide compliance has been shown repeatedly in the marketplace, with the inappropriate sharing of personal information within the CSP ecosystem, the limitations of relying on SaaS provider attestation reports for coverage of compliance controls, and when compliance conformance is the CSP responsibility. This effect is partly attributable to the customer's lack of contracting power and partly to the inability of the enterprise compliance function to understand, detect, and mitigate its loss of visibility. Hence, the ability to ensure that organizations maintain accountability as they transfer their responsibility for compliance with various regulatory requirements to their CSPs may be challenging. This ability requires an understanding of the nature and scope of the risk, accompanied by enhancements in the organization governance model. Greater integration between the compliance oversight that the IT department provides and the various other business unit and corporate level compliance functions is required. 2.6 Legal and regulatory requirements, standards, and security frameworks. Having a clear understanding of external requirements that should be contemplated in the cloud controls program is critical. Influential sources of external requirements are commonly based on key factors associated with the organization, such as industry sector, geographic location, and size. Although, in some cases, these laws and regulations may be cloud-specific, they usually apply more broadly, regardless of the type of technology in use. Within the cloud operating environment, there is a high degree of complexity, because varying laws and regulations may apply within different countries, states, and localities. External requirements help to support the reasons why policies, standards, and controls must be established within the organization, and they dictate what assurances may be required from the CSP. For example, U.S. federal government entities that leverage a cloud provider not only have specific control objectives to achieve for their responsibilities, but also require the CSP to provide evidence of adherence to the Federal Risk and Authorization Management Program, FedRAMP, requirements. An organization that outsources operations to a CSP remains accountable for adherence to regulations. Similarly, there are several standards available that can guide an organization cloud controls program. These standards are typically established to provide uniformity and guidance on techniques for addressing risk through controls. Although not always as enforceable as regulatory requirements, these standards can help an organization demonstrate that it is using sound practices to support its cloud operations. Laws, regulations, and standards, and many organization operations are constantly changing. Organizations should take care to maintain an understanding of the relevant laws, regulations, and standards. What was once deemed an irrelevant standard, law, or regulation may become relevant if the organization acquires an entity or otherwise expands operations. Additionally, as laws, regulations, and standards are updated to align with the evolving environment, there may be new requirements or implementation considerations for an organization. 2.6.1 Legal and regulatory requirements. Some requirements have their origins in regulations or laws required by specific industries. These requirements commonly exist to stop personal information from falling victim to theft or fraud. For example, if an organization deals with health sector providers that share confidential patient data in the United States, it needs to comply with the Health Insurance Portability and Accountability Act, HIPAA, and Health Information Technology for Economic and Clinical Health, HITECH, Act. HIPAA sets a national standard and requirements. 129 Certificate of To protect health and medical records and other forms of protected health information. The Ccak Act defines electronic health records and establishes breach notification requirements, among other things. In the U.S. financial services industry, companies must comply with the Gramm-Leach-Bliley Act, GLBA, in developing and maintaining information security programs to protect customers' private information. GLBA requires financial services companies to maintain a written information program that includes administrative, operational, and technical safeguards. Location-based laws occur at a variety of levels, from national laws to state and local laws. For example, within the United States, several states have standalone security and privacy laws that apply to operations within their borders or to consumer interactions within those states. Similar granularity occurs elsewhere in the world, such as in Europe and Asia. The European Union Industry Agnostic General Data Protection Regulation, GDPR, a primary regulation with broad reach, is centered on the concept of protecting the individual's right to privacy. It applies to any organization that processes information about persons resident in the EU, even if the organization is not physically located there. GDPR is not prescriptive about technology but requires organizations to take adequate steps to protect personal data. Organizations and their service providers must be aware of its potential applicability and implications. Requirements associated with laws and regulations commonly pass through an organization to relevant service providers. Relevant service providers, such as CSPs, must also demonstrate adherence. These requirements are typically codified in contractual arrangements, specifying what the cloud service provider must adhere to on behalf of its customer. For example, many U.S. government contracts require that cloud services comply with the Federal Information Security Management Act, FISMA. 35.5 The FedRAMP program was designed to support FISMA adherence by providing a standardized approach for security in the cloud, including a baseline of controls with various implementation levels based on risk, standard assessment activities and authorized third-party assessment firms. Examples of other regulations that might apply follow: the Sarbanes-Oxley Act, which sets requirements for publicly traded companies in the United States; 36.6 The Financial Instruments and Exchange Act, i.e., JSOX, which sets similar requirements in Japan; 37.7 Privacy Rules, including the Canada Personal Information Protection and Electronic Documents Act, PIPTA; 38.8 The Australian Privacy Principles, AP; 39.9 The New York Department of Financial Services Cybersecurity Regulation 4010 and the California Consumer Privacy Act 4111. The Family Educational Rights and Privacy Act, FERPA, which is related to educational records 4212. The EU Directive on Security of Network and Information Systems, NIS Directive, 4313. The U.S. Clarifying Lawful Overseas Use of Data, Cloud, Act, 4414, which was designed to speed access to data stored by US-based global companies to support criminal investigations. Organizations should have a clear understanding of applicable laws and regulations impacting their business operations, including 535 GovInfo, Public Law 107-347, December 17, 2002, www.govinfo.gov/contents. Impacts to control requirements. Extent of applicability to service providers. Processes to maintain the inventory. 2.6.2 Cloud Standards and Best Practices. Cloud Standards. Background. Cloud computing is a new technical and organizational IT paradigm that requires a new approach to certain aspects of information technology, networking and security, including new tools, best practices, frameworks, and, sometimes, new standards. During the early stages of development and adoption of cloud technologies, there was a long debate on the lack of standards dedicated to the cloud. Some key organizations, such as the European Telecommunications Standards Institute, ETSI, the European Commission and NIST, supported research to take stock of existing standards and analyze gaps that would prevent the safe adoption of cloud computing. Their studies consistently cautioned that cloud computing is not completely new and that many standards used for cloud computing are not cloud-specific. In the future, these standards may continue to evolve to better reflect cloud computing scenarios. 4515 This cycle of iteration and new standard release constantly repeats itself, with updates released frequently from a number of sources. The biggest gaps in the cloud standardization landscape were evident in the areas of interoperability and portability, service-level agreements, and, in part, security and privacy. During the period from 2009 to 2019, several standards, best practices and guidelines were published by international and national bodies, and some other sectoral organizations, communities, and forums. Notable examples of standard development organizations, SDOs, agencies, and research organizations developing cloud-relevant standards follow: ISO/IEC, ITUT, IEEE, among international SDOs NIST, US, European Union Agency for Cybersecurity, ENISA, and ETSI, Europe, Federal Office for Information Security, BSI, Germany, IMDA, Singapore, National Cybersecurity Agency of France, ANSI, France, among the national or regional institutions Cloud Security Alliance, CSA, DMTF, OASIS, OWASP. FIDO Alliance, OGF, IETF, among international organizations, community, forums, and alliances PCI Security Standards Council, PCI-SSC, among sector-specific organizations ISO/IEC, NIST, and CSA, over the last decade, produced the most comprehensive sets of work on cloud definition, architecture, security, privacy, and interoperability. ISO/IEC developed a series of standards, cloud definitions, example ISO/IEC 177884616, cloud architecture, ISO/IEC 177894717, cloud security, ISO/IEC 270174818, cloud privacy, ISO/IEC 270184919, cloud SLAs, ISO/IEC 19086 Parts 1545 ETSI, Cloud Standards Core 15,020, 25,121, 35,222 and 45,323, Virtualization, ISO/IEC 218785424 and ISO/IEC 190995525. NIST released the first and arguably the most widely used definition of cloud computing, Special Publication 1455626, a cloud computing reference architecture, SP 500-292-5727, and security architecture, SP 500-299-5828, an evaluation approach for cloud computing, SP 500-322-5929, and security and privacy controls, SP 800-536030. SP 800-53 started as a general-purpose framework but evolved to become cloud-relevant. Since its formation in 2009, the Cloud Security Alliance generated several best practices, guidelines, frameworks, and recommendations for cloud computing. Among the most relevant and widely used are Cloud Controls Matrix, CCM 6131, Guidance for Critical Areas of Focus in Cloud Computing 6232, Consensus Assessment Initiative Questionnaire, CAIQ 6333, Open Certification Framework, OCF 6434, Privacy Level Agreement, PLA 6535, GDPR Code of Conduct 6636, Cloud Enterprise Architecture 6737, on which the NIST Cloud Security Architecture is based, Software Defined Perimeter, SDP 6838, Standards Relevance for Compliance standards can serve as an additional input to an organization cloud controls program. Compared to laws and regulations, standards tend to apply more granularity in how to achieve control objectives and address risk. Organizations and cloud service providers leverage the standards for multiple purposes, including the following: 2050 ISO, ISO/IEC 19086-1:2016 Information Technology, Cloud Computing, Service Level Agreement, SLA, Framework, Part 1, Overview and Concepts, https://www.iso.org/standard/67545.html 2151 ISO, ISO/IEC 19086-2:2018 Cloud Computing, Service Level Agreement, SLA, Framework, Part 2, Metric Model, https://www.iso.org/standard/67546.html 2252 ISO, ISO/IEC 19086-3:2017 Information Technology, Cloud Computing, Service Level Agreement, SLA, Framework, Part 3, Core Conformance Requirements, https://www.iso.org/obp/ui/number ISO:/IEC:19086-3:1:3:ed-1:v1:2353 ISO, ISO/IEC 19086-4:2019 Cloud Computing, Service Level Agreement, SLA, Framework, Part 4, Components of Security and of Protection of PI. Defining their high-level compliance framework, speaking a common language, identifying potential controls to address known risk, driving uniformity in control techniques, demonstrating sufficiency of practices to address known risk for cloud customers. A key component of establishing a cloud controls program is clearly identifying the authoritative sources to use. Organizations usually identify several authoritative sources, although in some cases an organization opts to identify one standard or framework as the primary guiding principle. For a CSP, it is important to define its strategy and identify its target customer base. This approach will provide further clarity as to what standards to leverage in building a security program and which third-party assessment vehicles to obtain. Tip: like with laws and regulations, standards are routinely updated and their applicability to an organization evolves in alignment with organization changes. The cloud controls program should be structured and governed so that the framework is able to dynamically adjust in response to any relevant changes. Organizations usually maintain an inventory of laws, regulations, and standards mapped to requirements to facilitate this dynamic update process. Cloud security frameworks, general purpose information security frameworks, such as ISO/IEC 27001 and 27002, see Section 2.10 for additional details on ISO/IEC 27001, offer a good foundation to address key security requirements. They typically contain controls about the definition, implementation, enforcement, and review of policies for incident management, or about the testing of certain procedures, or about the enforcement of key principles, such as segregation of duties or least privileges. Those controls are relevant to cloud computing too. However, there are situations in which generic information security frameworks fall short in addressing the specificity of cloud computing. Certain areas such as the shared responsibility model, supply chain accountability, workload segregation, network segregation, virtualization, auditing, business continuity testing, and compliance deserve a new approach in the cloud. To fill the gaps existing in information security frameworks, several organizations over time decided to develop cloud-specific or cloud-relevant frameworks. NSA made the first attempt at the end of 2009 when it published the Information Assurance Framework, IAF. In 2010, the Cloud Security Alliance released the Cloud Controls Matrix. Commonly adopted frameworks. There are many security frameworks that provide foundations to help efficiently and effectively evaluate, assess, select, deploy, configure, manage, optimize, and secure cloud services. The frameworks described here are just some of those frequently referenced. These frameworks are often reused and extended, and the same experts often contribute to multiple frameworks, providing a level of consistency and familiarity. CCM. The Cloud Security Alliance Cloud Controls Matrix, CCM, is a set of security controls specifically designed to provide fundamental security principles to guide CSPs and to assist prospective cloud customers in assessing the 133 Certificate of Cloud Auditing Knowledge Study Guide, copyright 2021, Cloud Security Alliance and Ccak. Overall security risk of a cloud provider. The CSA-CCM provides a controls framework that provides a detailed understanding of security concepts and principles aligned to the Cloud Security Alliance security guidance. The foundations of the Cloud Security Alliance controls matrix rest on its customized relationship to other industry-accepted security standards, regulations, and controls frameworks, such as ISO/IEC 27001/27002/27017/27018, NIST, PCI, BSI, NISA, ISACA COBIT 2019 and NERC-CIP. The CCM augments or provides internal control direction for service organization control reports, attestations that CSPs provide. Chapter 3 is dedicated to the CCM. ISO/IEC 27017. The International Organization for Standardization, ISO, publishes a series of information security standards that can support a cloud controls compliance program. The ISO/IEC 27001 standard is broadly applicable to any organization, because it provides a specification for an information security management system, ISMS. ISO/IEC 27002 describes controls that can be put in place to adhere to the ISO/IEC 27001 standard. Further building on these foundational pieces, ISO published ISO/IEC 27017, which provides guidance on the information security aspects of cloud computing, recommending and assisting with the implementation of cloud-specific information security controls, supplementing the guidance in ISO/IEC 27002. ISO/IEC 27017 is a code of practice meant to provide cloud-related information on how to implement the security controls included in ISO/IEC 27002 and additional controls specific to the cloud computing context. The 7 new cloud-specific controls focus on areas such as shared roles and responsibilities, management of cloud assets, and segregation of cloud environment networks. The standard advises cloud customers and CSPs, with the primary guidance laid out side by side in each section of the standard documentation. ISO/IEC 27018 and ISO/IEC 27701. ISO/IEC 27018 is a code of practice for protecting personally identifiable information, PII, in public clouds acting as PII processors. ISO/IEC 27018 also can be relevant to organizations acting as PII controllers, which might be subject to additional requirements. It includes control objectives, controls, and guidelines for implementing measures to protect PII in line with the privacy principles in ISO/IEC 29100 for the public cloud computing environment. Like ISO/IEC 27017, ISO/IEC 27018 specifies guidelines based on ISO/IEC 27002, taking into consideration the regulatory requirements for the protection of PII which can be applicable within the context of the information security risk environment, of a provider of public cloud services. 6939. The target audience for this standard includes public and private companies, government entities, and not-for-profit organizations of any type and size. In 2019, the ISO Standardization Subcommittee, SC, 27 released ISO/IEC 27701:2019 Security Techniques, extension to ISO/IEC 27001 and ISO/IEC 27002 for Privacy Information Management, Requirements and Guidelines. 7040. This new standard is a privacy extension to ISO/IEC 27001. It is meant to provide organizations that have already implemented an information security management system, ISMS, with additional guidance for the protection of privacy. The goal is to support organizations interested in establishing a privacy information management system, PIMS. 3969 ISO/IEC 27018:2019 Information Technology, Security Techniques, Code of Practice for Protection of Personally Identifiable Information, PII, in public clouds acting as PII processors, www.iso.org/standard/76559.html 4070 ISO/IEC 27701:2019 Security Techniques, extension to ISO/IEC 27001 and ISO/ NIST SP 800-53. NIST SP 800-53 Security and Privacy Controls for Information Systems and Organizations provides a catalog of security and privacy controls for federal information systems and organizations to protect organizational operations and assets, individuals, other organizations, and the nation from a diverse set of threats and risks, including hostile attacks, natural disasters, structural failures, human errors, and privacy risks. 7141. NIST SP 800-53 was not created as a cloud-specific standard, but it has evolved to become cloud-relevant. The most recent publication, Rev 5, was published in September 2020. According to NIST, Rev 5 includes the following changes compared to Rev 4, consolidates the control catalog. Information security and privacy controls are now integrated into a seamless, consolidated control catalog for information systems and organizations. Integrates supply chain risk management. Revelation 5 establishes a new supply chain risk management, SCRM, control family and integrates SCRM aspects throughout the catalog. Adds new state-of-the-practice controls. These are based on the latest threat intelligence and cyber attack data, example controls to support cyber resilience, secure systems design, security and privacy governance, and accountability. Makes controls outcome-based. Revelation 5 accomplishes this by removing the entity responsible for satisfying the control, i.e., information system or organization, from the control statement. Improves descriptions of content relationships. Revelation 5 clarifies the relationship between requirements and controls, and the relationship between security and privacy controls. Separates the control selection processes from the controls. This allows the controls to be used by different communities of interest, including systems engineers, security architects, software developers, enterprise architects, systems security and privacy engineers, and mission or business owners. Transfers control baselines and tailoring guidance to NIST SP 800-53B. This content has moved to the new, draft, control baselines for information systems and organizations. BSIC 5. The BSIC 57242 standard is the Cloud Computing Compliance Controls Catalog, C5, for the German government-backed attestation scheme introduced by the Federal Office for Information Security, BSI, to help organizations demonstrate operational security against common cyber attacks within the context of the German government security recommendations for cloud providers. The basic criteria of the BSIC 5 standard reflect the minimum level of information security that a cloud service must offer when cloud customers use it to process information that has a normal need for protection. The minimum scope of an audit is defined by this criteria catalog. It is up to the cloud customer to assess the extent to which the basic criteria adequately reflect the protection needs of its information in its individual use case. For cloud customers whose information needs greater protection, additional criteria provide a starting point for conducting this assessment. CSPs may expand an audit based on the basic criteria by including the additional criteria for customers with higher protection needs. ANISA Cloud Computing IAF. The European Union Agency for Cybersecurity, ANISA, is an EU body whose mission is to achieve a high, common level of cybersecurity across the European Union. In 2009, ANISA published the Cloud Computing Information 4171 National Institute of Standards and Technology, Security, and Privacy Controls for Information Systems and Organizations, March 2020, https://envelopehubs.nist.gov/nistpubs/special publications/nist.sp.800-53r5 draft.pdf 4272 BSI, C5 Introduction, www.bsi.bun.de/n/topics/cloud computing/criteria_criteria_C5_introduction/C5_introduction_node.html 135 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 135. Assurance Framework 7343, IAF, which provides a set of assurance criteria designed to assess cloud-related risks, compare cloud offerings, obtain assurance from providers and reduce the assurance burden on cloud providers. The IAF was included as a component of NSA Cloud Computing Risk Assessment 7444, a study published to analyze the potential risk associated with adopting cloud computing. The IAF highlights the key questions an organization should ask when building a cloud security program to manage the fundamental risk identified in the report. The IAF has not been updated since 2009, although the principles it embodies are still relevant. Some control questions might be outdated and a few gaps can be present. Others, many security frameworks and compliance control sets exist, each focusing on a different targeted audience. The following sections present a subset of groups and communities. PCI DSS, the Payment Card Industry Data Security Standard, PCI DSS, was developed by the PCI Security Standards Council, PCI SSC, to establish consistent security practices for securing cardholder data. The standard is applicable to a variety of organizations that process or store credit card payment information. The standard includes a series of technical and operational requirements, related implementation guidance, and testing procedures for assessment firms. PCI DSS can inform the control requirement of an organization and the requirements that it may have of its service provider. Like with other standards, a cloud service provider can obtain an attestation of compliance from a qualified assessment firm to demonstrate to its customers its adherence to the requirements. PCI SSC Cloud Computing Guidelines. Through the Cloud Computing Guidelines 7545, the PCI SSC provides guidance on how to implement PCI DSS requirements in a cloud-based environment. Center for Internet Security, CIS, controls and benchmark. The CIS published useful tools to support cybersecurity, particularly the CIS controls and CIS benchmarks. The CIS controls 7646 include a set of technical controls generically applicable to information systems and networks. The CIS benchmarks include security benchmarks that are published for a variety of technologies and platforms. CIS provides cloud benchmarks 7747 for some major cloud service providers, such as AWS registered, Microsoft registered Azure and Google Cloud Trademark Enterprise Services. ANSI SEC Number Cloud. The National Cybersecurity Agency of France, ANSI, published the SEC Number Cloud Requirements Repository Essential Level, v.3, and the Advanced Requirements. The two documents contain requirements for secure cloud computing and cloud service providers applicable to organizations that provide services to administrative authorities. 4373, European Union Agency for Cybersecurity, Cloud. EUSEC. The EUSEC Consortium developed a framework for defining guidelines, procedures, and tools to foster mutual recognition for existing cloud security certifications. For a part of this work, it created a repository of security and privacy controls that includes a catalog of controls derived from CCM and the gap analysis between CCM and other cloud-relevant standards. It can be considered an extension of the CCM. The CSA used the results of the EUSEC work to develop addenda to CCM. The project was funded by the European Commission under the Age 2020 Framework Program, and the CSA was a member of the consortium and the scientific coordinator of the project. Resources are freely available at the EUSEC project website. 7848 Relationship between existing frameworks. Cloud-relevant or cloud-specific frameworks function as an extension of general-purpose information security frameworks, and there is consequently a strong relationship between them. The way that organizations select and use those frameworks largely depends on factors such as the following: the maturity of the organization security compliance program, whether the organization is born in the cloud or is moving to the cloud, business requirements, certification and attestation requirements. An organization that already has a security compliance program in place is likely to consider ways to extend the existing set of controls by integrating cloud-specific controls to fill potential gaps. An organization that is mainly cloud-based might adopt a cloud-native control framework, since that would cover all the necessary security requirements of best practices. An organization with a complex and mature approach to security and compliance might develop a tailored control framework involving several control frameworks. An organization operating in several business sectors and countries may adopt and adhere to the requirements of several frameworks to present its compliance posture in the easiest way possible to a customer or authority of reference. Regardless of the approach and framework selected, it is important for the cloud customer to map the organizational security requirements with the chosen framework or frameworks, in the case of the multi-framework approach, to clearly understand the relationships between them. There is considerable overlap between the requirements included in the various control frameworks. Often, different frameworks include controls that include semantic differences, but that are substantially the same from a practical point of view. For example, according to the results of a study 7949 conducted by the EUSEC Consortium, the controls included in the CCM cover approximately 85% of the requirements included in ISO/IEC 27001/2/17/18, C5, ICPA TSC and other standards. 4878 EU Security Certification, the European Security Certification Framework, EUSEC, www.sec-cert.eu. 4979 EU Security Certification, European Security Certification Framework D1.2 Security and Privacy Requirements and Controls, May 28, 2019, https://cdn0.scrvt.com/focus/5C1E85C636D71D7C/C559F8E809FC/EUSEC D1.2 Security and Privacy Requirements and Controls V1.4. PDF 137 Certificate of Cloud Auditing Knowledge Study Guide. Copyright 2021 Cloud Security Alliance and ISACA. All rights reserved. 2.7 Defining Controls. 2.7.1 Controls. ISO defines a control as a measure that modifies a risk. 8050 According to ISACA, internal controls include the policies, standards, procedures, and other organizational structures that are designed to provide reasonable assurance that business objectives will be achieved, and undesired events will be prevented, detected, and corrected. 8151 For example, installing antivirus software is a technical control that aims to reduce a broad set of risk related to malware infections. A control is any measure that can help safeguard the security of physical property, information, computer systems, or other assets, or any countermeasure that can help avoid, detect, counteract, or minimize security risk to physical property, information, computer systems, or other assets. Controls can be classified by several criteria, but there are three main categories: preventive measures reducing or eliminating the likelihood or impact of a risk. Note that ISO redefined preventive to mean actions to address risk and opportunities. 8252 Detective measures that detect and characterize events. 8353 That lead to the realization of a risk. Corrective measures designed for risk impact reduction after detection. An example of a preventive control is an antivirus software installation. A detective control can include an intrusion detection system that monitors network traffic for suspicious activities. A corrective control can be the system spraying fire suppressant into a data center room in case of a fire, or an AWS Lambda function closing an S3 bucket that is open to the internet. Controls are also often categorized 8454, 8555 according to their nature, as follows: technical controls, logical, software, hardware, and related technologies that are used to protect assets, including antivirus measures, encryption, and network filtering, administrative/organizational controls, policies, regulations, standards, and procedures that constrain organization management and protection of its assets, including measures such as training, background checks on personnel, and supply chain management. 8656 physical controls, devices that protect access and integrity of the environment where computing resources and personnel are located, including locks on doors, guards, and security cameras. High-level or descriptive control languages may express requirements covering more than one of the categories described. See Chapter 4 for additional details about controls categories and examples. 5080 ISO/IEC 27000:2014 5181 ISACA, glossary, www.isaca.org/pages/glossary.aspx?TID =1506 char =I5282. A security system by its very nature is a preventive tool. Preventive tool. Therefore, preventive action has been Figure 2.9 shows 3 examples of controls from the CSA Cloud Controls Matrix version 3.0.1, each covering a different control category. Controls such as the one found in control frameworks like the CSA CCMB 3.0.1 are high-level controls that combine several control categories. Consider, for example, CCM EKM04. Example, CCMV 3.0.1 EKM04 Platform and Data Appropriate Encryption. Example AES 256, in open/validated formats and standard algorithms shall be required. Keys shall not be stored in the cloud, i.e., at the cloud provider in question, but maintained by the cloud consumer or trusted key management provider. Key management and key usage shall be separated duties. Although this is globally a preventive control, its content can be divided into 2 parts. The first sentence describes a technical control, platform and data appropriate encryption. Example AES 256, in open/validated formats and standard algorithms shall be required. The second and third sentences are mainly organizational matters. 2.7.2 Control objectives. Some control frameworks group controls together under a common control objective. A control objective is a statement describing what is to be achieved as a result of implementing controls. 8757 Control objectives are more abstract, or high-level, statements than controls. In practice, not all audit frameworks make the distinction between controls and control objectives. For example, ISO/IEC 27002 provides a catalog of control objectives, with each associated with one or more controls. NIST SP 800-53 refers only to controls, and control enhancements. Other sources use a different terminology altogether to refer to control objectives. For example, the ICPA 8858 prefers the term trust services criteria in the context of attestations or consulting engagements. 8959 to refer to control objectives. The following examples from the annex of ISO 27001:2005 illustrate the difference between a control and a control objective. Control objective, A.9.1 Secure areas to prevent unauthorized physical access, damage, and interference to the organization's premises and information. Control, A.9.1.4 Physical protection against damage from fire, flood, earthquake, explosion, civil unrest, and other forms of natural or man-made disaster shall be designed and applied. 5787 from ISO/IEC 27000:2001 5888 American Institute of Certified Public Accountants, www.aicpa. 2.7.3 Designing and selecting controls. The design and selection of controls in an information system is not an activity that stands on its own, but is part of the broader process of risk management. By definition, controls are countermeasures that address a risk. Selected and implemented controls should be regularly reviewed for effectiveness. Organizations may alter or replace ineffective controls to meet their objectives. After risk is identified, priority goes to the mitigation of the highest risk, through the selection of appropriate controls. Although risk should be treated according to its level of severity, high, medium, low, it may be possible to treat more than one risk severity at the same time. In some cases, it is acceptable not to treat a risk condition, simply because it is sufficiently low, or because the cost of treating the risk far outweighs the cost of the realization of the risk itself. Each organization has a different risk tolerance. Best practices encourage documenting and reporting the management decision to accept a risk to the executive team, board of directors, or audit committee of the board of directors. Controls can be designed and selected to reduce the impact or likelihood of a risk, or both. For example, using specific cryptographic hashing techniques 9060 to protect user passwords is a way to reduce the impact of a breach of confidentiality of the user database containing the passwords, because those passwords are not exploitable by the adversary in most cases. Likewise, removing all administrative remote access mechanisms to a virtual machine, SSH, remote web console, etc., reduces the likelihood of a remote compromise. A just-in-time access approach reduces the time access is available to the machine, thus reducing the window of opportunity for unauthorized access. In the context of cloud computing and the use of third-party services, it is mandatory to take into account the controls that the third party already offers through security tools, APIs, and configuration options. However, those controls may not be sufficient to address the identified risk, and it may be necessary to complement or supplement them with additional controls. Risk management is an ongoing process. After controls are implemented, it is important to continuously monitor and assess their effectiveness. Gaps and shortcomings may be identified, requiring controls to be modified, removed, or added. Moreover, as the organization grows and threats evolve or change, new risk emerges, requiring the selection and implementation of new controls. In a public cloud with a DevOps IT environment, the traditional risk management process is challenged, and it might be unable to keep up with the pace of daily changes and deployments to production. In such cases, the DevOps team is often responsible for mitigating or managing risk daily. The risk management team checks afterward if DevOps followed processes and procedures and generated the required evidence. The internal audit function typically determines if the approach used is mature and effective, by assessing whether the action taken addresses the risk and supports the organization objectives, and by evaluating the balance between preventive, detective, and corrective controls. 2.7.4 Control frameworks. Risk management involves the identification of risk followed by the selection of controls that mitigate them. While every organization faces different risk and uses different information systems, there are many commonalities in the way risk must be addressed, leading ultimately to many commonalities in control objectives. All organizations, including the smallest, need clearly defined information security management practices and governance. Based on the experience gained by security practitioners over the years, this led standardization organizations to develop comprehensive and logically structured catalogs of controls that can be reused and applied across a wide range of organizations. These catalogs are often referred to as control frameworks. 6090 for example, the PBKDF2, Password-Based Key Derivation Function 2, 140 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 140. The use of a standardized control framework does not mean that an organization implements all controls in the framework. Some proposed controls might not be relevant and are ignored. In some cases, organizations might add specific controls that may be missing from the framework. In other cases, organizations adopt alternative controls that achieve the same results as the ones that the framework suggests. The selection of a control must be grounded in the results of a risk analysis, and a control framework only provides a well-defined set of measures for risk treatment. Using a standardized control framework has many benefits, including the following. It anchors the implementation of security controls into a well-known reference system and language recognized by many practitioners across an industry. It supports auditors' efforts to assess an information system based on a well-defined set of controls, enabling the following actions: comparisons of cloud security features across different time periods or different cloud services, gap analyses of what a CSP offers versus what the customer requires, benchmarking of competing cloud services. Example, in the context of procurement, it enables the building of trusted certification schemes by ensuring that information systems are assessed with a comparable set of criteria. Control frameworks are usually organized in a hierarchical manner. First, controls are grouped into domains designed to help understand their broad scope. Domains may also be called families or chapters. Domains may help divide audit and compliance efforts across organizations. For instance, controls grouped together under the physical and environmental security domain and those grouped under the configuration management domain might be overseen by different managers and auditors. Some control frameworks break down each domain into a set of control objectives, and then break down each control objective into one or more controls. Other control frameworks adopt a simpler hierarchy that simply groups controls into domains. Most control frameworks provide implementation guidelines for each control. Most control frameworks assign a unique control identifier to each control, i.e., a short name or number that facilitates cross-referencing. Examples: ISO/IEC 27002:2013 is a generic control framework for information security management systems. The standard defines 14 domains, each divided into control objectives and then further subdivided into controls. A total of 35 control objectives cover 114 individual controls. NIST SP 800-53 is a generic control framework designed for U.S. federal information systems. The standard defines 18 control families covering a total of 231 controls. Figure 2.10. Controls are classified into 3 baselines: low, moderate, and high, each designed to address a particular risk level selected through a preliminary risk analysis. The CSA Cloud Controls Matrix v3.0.1 is a control framework designed to specifically address cloud services and cloud threats. The CCM is divided into 16 domains covering 133 control objectives. Figure 2.11. See Chapter 3 for more details on the CSA Cloud Controls Matrix. 2. The CSA Cloud Controls Matrix v3.0.1 is a control framework designed to specifically address cloud services and cloud threats. The CCM is divided into 16 domains covering 133 control objectives. Figure 2.11. See Chapter 3 for more details on the CSA Cloud Controls Matrix. 2.7.5 Mapping controls across control frameworks. Many organizations need to show compliance with more than one control framework to accommodate customers and comply with regulations across industries and geographical regions. It is important to understand which compliance frameworks are relevant to the cloud services that an organization uses or offers. Organizations assessing compliance with more than one framework have 2 choices: assess compliance with each framework separately, starting each time from scratch, or look for commonalities between frameworks and avoid duplication of work where possible. Figure 2.10 NIST SP 800-53R4 Control Families: ID Family AC Access Control MP Media Protection and Awareness and Training PE Physical and Environmental Protection O Audit and Accountability PL Planning CA Security Assessment and Authorization PS Personal Security CM Configuration Management RA Risk Assessment CP Contingency Planning SA System and Services Acquisition IA Identification and Authentication SC System and Communications Protection IR Incident Response SI System and Information Integrity MA Maintenance PM Program Management. Figure 2.11 CSA CCMV 3.0.1 Control Domains ACE Application and Interface Security AAC Audit Assurance and Compliance BCR Business Continuity Management and Op Resilience CCC Change Control and Configuration Management DSI Data Security and Information Lifecycle Management DCS Data Center Security EKM Encryption and Key Management GRM Governance and Risk Management HRS Human Resources Security IM Identity and Access Management IVs Infrastructure and Virtualization IPY Interoperability and Portability MOS Mobile Security SEF Secretary Incident Management eDisk and Cloud Forensics STA Supply Chain Management Transparency and Accountability TVM Threat and Vulnerability Management Source Cloud Security Alliance Cloud Controls Matrix CCM Working Group 142 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 142. There are many common controls across different frameworks. The wording may differ, but the objectives are often the same. Therefore, the second approach makes a lot of sense. Organizations are encouraged to maintain mappings between the different control frameworks that they review. See Chapter 3 for more information on cross-mapping of control frameworks. 2.7.6 Mapping controls to architectural implementations. Controls are reusable across the organization and typically are matched to a framework, as discussed in sections 2.6.4. and 2.6.5. However, cross-mapping efforts do not just involve frameworks. Extending controls to a reference architecture 9161 creates better visibility into the specific organizational and technical structures. When presenting findings to non-auditors, architectural depictions are more effective than an auditor's spreadsheet for showing where a control will apply. Several references exist, which are typically based on an organizational focus or a technology. Defining controls from policies and objectives to activities and controls before mapping architectures, it is essential to understand the relationships of control components, objectives, activities, and controls, and associated governance documentation, identifying the control components from the top level, strategic policy document to the implementation level processes and control measurements. Figure 2.4 depicts the derivation of document and control components. By maintaining traceability through this chain, auditors may prove that implemented controls map to the starting requirements. The relationships within Figure 2.12 follow: Requirements, Section 2.5, Define Policies, Sections 2.3.3.3 and 2.4.1.3, and Influence Control Objectives. Control Objectives, Section 2.6.3.1, Map to Policies. Organizational Standards map to Control Objectives. Baseline configurations flow from organizational standards and define platform-specific functionality. 6191 Read, P. Reference Architecture, the best. Control Activities, Section 2.6.3.1, are actions, generally described in policies, standards, and procedures, that help management mitigate risk to ensure the achievement of objectives. 9262 Controls map to a corporate standard. Controls Measurements, Section 2.8, Map to Controls. Many-to-many mappings requirements introduced through policy, designed into baselines and eventually measured through metrics should be tracked for performance. Typically, as part of systems engineering, a many-to-many mapping exists, with specific controls satisfying multiple requirements. The most direct method of tracking comes in the form of a Requirements Traceability Matrix, RTM. Although RTMs are common within government contracting, they are not found as frequently in enterprise environments. An RTM may include feature requests from current customers and necessary implementation requirements. Features promised to customers through contracts may be tracked with requirement IDs, Figure 2.13. The test cases may involve interplay, e.g., to have feature A, feature B is a prerequisite leading to additional regression analysis. Although RTMs are most easily understood as a method of guaranteeing coverage, software beyond the spreadsheet allows faster compliance audits and test case coverage. These software products may also be used past requirements tracking and focus on the broader GRC program. Architecture in the cloud. This section describes three types of cloud architectures. Organizationally focused architectures. The U.S. federal government adopted the NIST Original Enterprise Architecture Model 9363 in the 1980s. The Generalized Enterprise Reference Architecture and Methodology, GERAM, 9464 of the 1990s. Extended Enterprise 6292. Shandel, A. P. Foster, COSO Internal Control, Integrated Framework, an Implementation Guide for the Healthcare Modeling and provided building blocks for engineering efforts. Business and IT collaborators at Ccak created COBIT registered 9565, Control Objectives for Information Technology, which is intended for end-to-end business and IT functional integrations, and is now COBIT 2019. One of the longer-running information technology architectures, the Information Technology Infrastructure Library, ITIL, 9666 began with efforts by the UK government to describe the IT landscape. Axelos, a public-private venture, owns the current, fourth, ITIL incarnation. Technology architectures in the computer environment. Architecture is the conceptual structure and logical organization of a computer or computer-based system. The data center layout diagrams describing physical devices and their connections fit this description. There are multiple architectures within the IT space. Administrators reference abstractions from physical devices to component groups or block network designs as architectures. Software developers may be focused on an individual technology, such as the Enterprise Edition of the Java 9767 product. All these examples point to constrained organizational units or limited environments. Cloud architecture. CSPs trend in the same direction, often describing their solution components as a complete architecture solving all use cases. AWS created the Well-Architected Framework 9868 as a guide for implementing its service catalog with a focus on cost, reliability, security, and performance. Microsoft released a cloud adoption framework to create and implement the business and technology strategies necessary for your organization to succeed in the cloud. 9969 The Google Cloud Platform trademark directs users to the best designs in GCP migration. 170 CSA Trusted Cloud Initiative. Similarly, the CSA Trusted Cloud Initiative sought to create a holistic architectural model for a complete set of necessary cloud components. The project addressed not just the confined functionality of ITIL or cybersecurity, but the broad interpretation of business, IT, security and technology services. Technology services. The project continued evolving, eventually becoming the CSA Enterprise Architecture, EA, Figure 2.14, with a broader understanding of the ubiquity of cloud. NIST adopted the EA in NIST SP 500-299 as part of its cloud reference architecture, solidifying the importance of the CSA approach. EA components. The Enterprise Architecture, EA, consolidates and coordinates features from 4 organizational architectures, Figure 2.14. 6595 Ccak, COBIT, an Ccak framework, HTTP. The EA guiding principles enable users to develop cross-platform capabilities and patterns, define protections that enable trust in the cloud, and provide direction to secure regulated information, all with an expectation of elastic, flexible, and resilient support for multi-tenant and multi-landlord platforms. The EA4 domains and its ideas/best practices/models genesis follow: Business Operation Support Services, BOSS, Sherwood Applied Business Security Architecture, SABSA, 171 Information Technology Operation Services, ITOS, Information Technology Infrastructure Library, ITIL, 102 Technology Services, including Infrastructure, Infra SRV, Information, Info SRV, Application, AS, and Presentation, PS, Services. The Open Group Application Framework, TOGAF, 103 Security and Risk Management, SRM, the Jericho Forum 10474. The enterprise architecture consolidates the common components of these models, relying on interactions with the other three components to establish a tighter relationship for the whole. The EA can provide a presentation layer for control coverage and a communication medium for auditors, engineers, and security and management professionals. 71101 SABSA Enterprise Security Architecture, https://sabsa.org 72102 OPCIT Axelos 73103. The Tying the EA to the CCM. The all-encompassing topology of the enterprise architecture provides a perspective on the cloud. Because controls are reusable, there are alignments between the enterprise architecture and frameworks, such as NIST, ISO, or the Cloud Controls Matrix. As parts of the CSA toolkit, the EA working group went with the CCM framework. The mapping constitutes an attempt to quantify the relationships of the 359 components in the EA and the 133 controls in the CCM, a 48K cell CCM to EA. There are perspectives and edge cases within the CCM to EA mapping spreadsheet 10575 to understand, which necessitates a usage guide. 10676. The mapping should not be used as gospel, as CCM entries may provide only partial detective, corrective or preventive controls over a particular EA component. The mapping offers users details on where to look, but does not document the nuances of completeness of control for that component. Where architectural elements show no coverage, organizations should look for gaps in control objectives. Gap identification methodologies. A comparison of any two architectural designs or framework perspectives reveals differences. Gaps occur, even in holistic frameworks, complete architectures, and extensive regulatory requirements. There is a natural inclination to immediately remediate a finding with another arbitrary control. Instead, organizations may progress from the policy level with purpose, and work down to final controls and measurements. Figure 2.12 depicts the intersections of relationships between policies, standards, guidelines, and processes with control objectives, control activities and control implementations. One example of a relationship between the application and interface security domains is the Data Security and Integrity Control Group, ACE04. The enterprise architecture containers and processes show 125 mapping suggestions for review in the EA to CCM mapping. See the example in Figure 2.15. Working down from the policy level in the CCM, the application and interface domain mentions the following: ACE04, application and interface security. Rightward arrow. Data security/integrity policies and procedures shall be established and maintained in support of data security. 1077775 105 CCM to EA mapping 76 106 CCM to EA mapping usage guide 77 107 CSA Enterprise Architecture Reference Guide 2020. Figure 2.15 Enterprise Architecture. The ACE04 row 11 maps to 125 items covering aspects of the enterprise architecture, e.g., security and risk management. Rightward arrow. Governance, risk and compliance. Rightward arrow. Compliance management analyzes compliance with all specified internal information security policies, control standards, and procedures. 10878. There are several policy callouts throughout the frameworks, CCM and architectures. The CCM ACE04 and EA security and risk management requirement examples both call for policies. All policies fulfill requirements, although none of the tools listed identify what should serve as descriptive materials, discussed further in section 2.7.3. Requirements must be pulled from a variety of organizationally specific laws and contracts. Figure 2.12, section 2.6.6. Then, control objectives can be set for this policy and mapped into company standards. Those standards create a baseline configuration for the environment. The EA can help with the baseline configuration, visually identifying missing elements. In Figure 2.16, example of a tailored EA, color-coded progress indicators identify gaps within the 4 domains. Several coverage gaps and tailoring activities appear within the Security Monitoring Services container, which can prompt further discussions with the organizational teams, security operations, legal, and incident response. 2.8 Identifying technical and process controls. 2.8.1 Operationalizing security controls. The security controls found in standard control frameworks, like ISO/IEC 27001 or the CSA/CCM, describe security measures or objectives in a technology-neutral language that is universally applicable to most information systems. For implementation in a real-life information system, these controls need to be translated into technical, organizational, and physical measures tailored to the underlying platform, architecture, organizational structure and governance of the target information system. The translation of standard security controls may take many forms, updating procedures and their supporting documentation to address the organizational dimension of controls for business processes and human resources, reviewing the organization governance to ensure that management is in command of information security, reviewing contracts and adding appropriate clauses in contracts with entities in the supply chain and employees to cover identified risks, selecting security tools, technologies and relevant vendors to support control requirements for the confidentiality, integrity, and availability of information system assets. Figure 2.17 Element Mapping, Business Operations Support Services, BOSS, Source, Cloud Security Alliance, Enterprise Architecture 2.0 149 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program Business Operations Support Service. Addressing physical and environmental risk with appropriate technologies, processes and personnel training and awareness. The operationalization of controls must be scrutinized. It can create security gaps or a false sense of security if the concrete security controls do not cover the higher level security requirements that they are intended to embody. 2.8.2 Cloud-specific controls. It is necessary to translate generic, technology and vendor-agnostic security controls into measures that are tailored to a specific technology, platform, and architecture. The control operationalization process in the cloud may differ from traditional IT mainly for three reasons. The impact of the shared responsibility model ties the operationalization of a control to a combined effort from multiple parties. For instance, the CSP might need to expose an API for the customer to implement a certain monitoring control. Technologies have inherent differences. For example, while firewalls were a suitable solution for network segmentation and isolation in traditional IT, software-defined networking, SDN, workload isolation, and security groups offer much more powerful alternatives in IaaS deployments. The scale and pace of change of the cloud service imposes the need to implement automated controls. In general, it is important to avoid the temptation to replicate traditional IT practices in the cloud when better cloud-native approaches exist. Controls from a cloud perspective. In traditional IT environments, emphasis is placed on people executing processes to fulfill corporate governance requirements. Authentication and authorization are assigned to roles with the familiar titles of administrator or user. Email requests and managerial authorizations verify needs and budgets. Perimeter protections, such as firewalls and data loss prevention, DLP, contain specific threats to network connectivity, including administrator activity. In contrast, the main motivators of CSPs include automation, speed and, to some extent, portability. Service-specific accounts, i.e., object storage, cryptography, and compute, and attribute-based access control, ABAC, provide least privilege methods to counter threats that do not exist within the enterprise. The velocity of execution goal precludes man-in-the-loop processes, avoiding delays through scripting, notifications, and message queues. Whereas firewalls prevent network probes, decoupled services in cloud-native designs necessitate corrective controls. These controls addressing physical and environmental risk with appropriate technologies, processes and personnel training and awareness. The operationalization of controls must be scrutinized. It can create security gaps or a false sense of security if the concrete security controls do not cover the higher level security requirements that they are intended to embody. 2.8.2 Cloud-specific controls. It is necessary to translate generic, technology and vendor-agnostic security controls into measures that are tailored to a specific technology, platform, and architecture. The control operationalization process in the cloud may differ from traditional IT mainly for three reasons. The impact of the shared responsibility model ties the operationalization of a control to a combined effort from multiple parties. For instance, the CSP might need to expose an API for the customer to implement a certain monitoring control. Technologies have inherent differences. For example, while firewalls were a suitable solution for network segmentation and isolation in traditional IT, software-defined networking, SDN, workload isolation, and security groups offer much more powerful alternatives in IaaS deployments. The scale and pace of change of the cloud service imposes the need to implement automated controls. In general, it is important to avoid the temptation to replicate traditional IT practices in the cloud when better cloud-native approaches exist. Controls from a cloud perspective. In traditional IT environments, emphasis is placed on people executing processes to fulfill corporate governance requirements. Authentication and authorization are assigned to roles with the familiar titles of administrator or user. Email requests and managerial authorizations verify needs and budgets. Perimeter protections, such as firewalls and data loss prevention, DLP, contain specific threats to network connectivity, including administrator activity. In contrast, the main motivators of CSPs include automation, speed and, to some extent, portability. Service-specific accounts, i.e., object storage, cryptography, and compute, and attribute-based access control, ABAC, provide least privilege methods to counter threats that do not exist within the enterprise. The velocity of execution goal precludes man-in-the-loop processes, avoiding delays through scripting, notifications, and message queues. Whereas firewalls prevent network probes, decoupled services in cloud-native designs necessitate corrective controls. These controls are typically reactive to stimuli without human interaction. The contrast between traditional IT and cloud environments exhibits itself most readily in the cloud metastructure. The cloud metastructure, as defined in CSA Guidance V4, includes the protocols and mechanisms that provide the interface between the infrastructure layer and the other layers. The glue that ties the technologies and enables management and configuration. 10,979. It includes the management plane components, which are network-enabled and remotely accessible. This waterline in the shared responsibility model defines where the CSP duties end and the consumers begin. It varies based on the service, platform, infrastructure, SPI, model, with the IaaS services most resembling typical enterprise controls. As organizations relinquish more operational aspects to the CSP, the technical and process controls become fewer, but harder to manage. Metastructure aspects are vendor-specific, and necessitated controls cannot be readily moved for existing enterprise integration. Asking a public CSP to trust an enterprise Active Directory or LDAP controls creates a situation ripe for fraud. A CSP identity and access management (IAM) components require flexibility from the smallest of individual 79109 Cloud Security Alliance security projects to the largest financial services and commercial undertakings. Organizations must adapt to new cloud-specific norms. An example of control adaptation is the proliferation of single sign-on (SSO) options or universal second factor (U2F) credential storage integration devices. In the cloud, controls use new capabilities. For example, the introduction of new categories of services, such as function as a service (FaaS) 1080 enhances the concept of scripting. This allows automatic creation of new controls, a capability that is not necessarily available in an on-premises infrastructure. For instance, a FaaS corrective control may replace deleted credentials after notification. This does not have an enterprise analog. A preventive FaaS infrastructure control can proactively adjust security group administrative port assignments, i.e., SSH or RDP, from world open 0.0.0.0/0 to the IP range constraints of an organization. Mitigating cloud controls. Not all cloud control offerings meet organizational needs. While operationalizing a control, the cloud customer might face different possible options that are combined in different control implementation scenarios, as follows. The CSP can offer security capabilities that fully satisfy the customer requirements. The CSP can meet most of the adoption requirements, although there may be unacceptable feature implementations that require additional mitigations. Several organizations within the financial services industry use the cloud but are not comfortable with the cryptography solutions that the CSP offers. Whether they better trust their overall crypto system or because they are forced to directly manage the encryption keys for compliance reasons, these customers might decide to look at enterprise implementations such as on-site hardware security modules, HSMs. The CSP does not integrate with other solutions and requires specific third-party workarounds or custom application development. The CSP provides a rich set of APIs that can be used by the cloud customer or third-party security vendor, example CASP, to develop security capabilities in addition to the ones offered by the native cloud service, example security monitoring solutions and DLP. Cloud deployment model impact on control operationalization. The operationalization of controls may vary considerably between different deployment models, especially for technical controls. For example, in the CSA Cloud Controls Matrix, see Chapter 3, and the CCM Shared Responsibility Mapping 11181, it is possible to identify a variation between CSP, shared and consumer. On a pure IaaS platform, 100 of the controls remain under the responsibility of the cloud customer, while 129 are the CSP responsibility. This means that the customer has much flexibility in the operationalization of controls and can select among different solutions to best match its requirements. On a SaaS platform, most of the responsibility is with the CSP, with 130 controls as its responsibility, and only 83 controls are directly controlled by the consumer. In these cases, the CSP falls under the supplier relationship controls and the SaaS provider has responsibility to confirm that it has adequately validated that the CSP's controls meet its required specifications. The operationalization of controls is usually constrained by the security tools and configuration options embedded in the platform. The downside is that these tools and configuration options may not. 8110 C IBM Cloud Education. What is FaaS? Function as a Service. July 30, 2019. www.ibm.com/cloud/learn/FaaS. FaaS, Function as a Service, is a type of cloud computing service that allows you to execute code in response to events without the complex infrastructure typically associated with building and launching microservices applications. Hosting a software application on the internet typically requires provisioning and managing a virtual or physical server and managing an operating system and web server hosting processes. With FaaS, the physical hardware, virtual machine operating system, and web server software management are all handled automatically by your cloud service provider. This allows you to focus solely on individual functions in your application code. 81111 Google Sheets, https://docs.google.com/spreadsheets/d/1curvyfdwx3jql4ql5cbsy HME0LE_k52FPRVJ5UI/edit151 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 151. Match the requirements of the specified control, and there may need to be additional compensating controls in some cases. 2.8.3 Evaluating specific technical controls. Identifying sources for controls. The selection of an authoritative reference source for creating a baseline configuration depends on where the organization is in the cloud migration process. If a consumer has not chosen a CSP and is in the evaluation phase, industry organizations can help narrow the field through benchmark control lists and features comparisons. If the CSP decision has already been made, vendor requirements and vendor-specific product benchmarks may assist in creating a secure implementation. Industry organizations, in addition to vendors, industry groups with specific focuses may provide direction. The SENS Institute put together a large library of early compliance controls literature. Although the institute still produces a large volume of white papers, it handed over the top 20 critical controls to the Center for Internet Security, CIS, 11282 for upkeep. CIS began generating new collaborative benchmarks, working with CSPs and other groups, such as the CSA, for product and technology-specific implementation methodologies. Application developers pay attention to the Open Web Application Security Project, OWASP, and its top 10. 11383 Center for Internet Security registered, CIS registered. The Center for Internet Security offers security controls and cloud-relevant benchmarking. The benchmarking provides prescriptive guidance for establishing a secure configuration posture on many technology and vendor-specific services and products, including the following: cloud providers, Amazon Web Services registered, AWS, Microsoft registered, Azure, Google Cloud Platform trademark virtualization, Docker registered, Kubernetes registered, VMware registered server. The CIS benchmarking includes several other categories: database servers, desktop servers, web servers, networking devices, operating systems. 82112 Center For Internet security, the 20 sys controls and resources, www.cisecurity.org/controls/sys-controls-list 83113 OWASP, OWASP top 10, https://owasp.org/www. Open Web Application Security Project, OWASP. The Open Web Application Security Project registered, OWASP registered, is a non-profit foundation that works to improve the security of software. 1484 Its community-led software projects are open source. One of its best-known projects, the OWASP Top 10, is a standard awareness guideline that is globally recognized by developers as the first step towards more secure coding. 1585 Many cloud services incorporate the Top 10 into their product offerings, including major web application firewalls, WAFs, AWS WAF, Microsoft Azure Application Gateway WAF, and Google Cloud Armor WAF. CSA** is the CSA Security and Privacy Governance and Compliance Program. Consumers may use it for understanding CSP implemented controls through CCM or Consensus Assessments Initiative Questionnaire, CAIQ, evaluations, and for identifying shared responsibilities. See Chapter 9 for further details. Vendor sources. The best sources of information for IaaS and PaaS services are the CSP documentation repositories. Mature CSPs include shared responsibility mappings against common frameworks, such as the AWS Standardized Architecture for NIST-based assurance frameworks. 11686 As a product consumer, CSPs should share under NDA their SOC2, Service Organization Controls 2, Type 2 assessment findings. ASOC2 Example 11787 from the Microsoft library requires customer sign-in prior to download. These documents should direct users to customer control responsibilities. Additionally, it is customary to have CSP experts on site to assist further with implementing and configuring these controls. Determining baseline configurations. The standards and associated platform-specific controls required for baseline configurations are best defined in organization security policies. Security policies are abstract, directing security control objectives and not specific products or implementations. For example, a security policy may state that the organization must protect data at rest with encryption. In response, as part of its corporate standard, the organization may require virtual machine hard disk encryption. The option of following the standard by implementing encryption on its own may be technically infeasible or unreasonably expensive. Instead, the company may consider using CSP managed services for encryption controls. Each CSP has its own dedicated service that aims to satisfy customer requirements and control objectives. CSP product comparisons. Depending on the products and CSP, similarities and differences abound. Although there are many generic cloud concepts, the implementation decisions determine the details. CSPs decide on features based on business decisions pursuing vertical sectors, satisfying customer requests, continuing legacy support, or meeting legislative requirements. Public CSP offerings typically satisfy most of the demand, with certifications for healthcare, financial services, or energy regulation. See Section 2.6. However, there are special community clouds set up with default controls that differ significantly from public options. For example, 84114 OWASP, who is the OWASP registered foundation, https://owasp.org 85115 OWASP, OWASP top 10, https://owasp.org/www-project-top-1086 116 AWS, standardized architecture for NIST-based assurance frameworks on the AWS cloud, quick start reference deployment, January 2016, https://docs.aws.amazon.com/quickstart/latest/compliance-nist/welcome.html 87100 AWS GovCloud 11888 includes international traffic in arms restrictions, ITAR, 11989 requirements Microsoft G Cloud 12090 United Kingdom Government Cloud includes GDPR restrictions AWS Intelligence Cloud 12191 US-based intelligence agencies meet special hardware implementations and connectivity requirements Microsoft Joint Enterprise Defense Infrastructure, JEDI, 12292 US Department of Defense meets special hardware and connectivity requirements Google Cloud for Government 12393 offers worldwide government agency support. Other CSPs target specific community spaces with wholly focused products. Example: the Armor 12494 platform. A complete analysis of all the CSP options is beyond the scope of this study guide. Examples of product implementations and the design requirements that they satisfy are shown in the following: application protection and encryption requirements analysis. Application protection requirements analysis and baseline configuration. This is a common requirement set for mitigating software vulnerabilities and external network threats to an application. Organizations can implement their own instance-based web application firewall, WAF, or outsource it to a third-party CASP. The complexity, cost, and additional supply chain risk may not prove of benefit to the organization when compared with the CSP service implementation. Sample application access protection requirements include the following: a WAF shall be used to protect data with a critical data classification rating. A rule set shall be used based on OWASP Top 10 12595. Additional WAF rules may be added when deemed necessary. WAF shall utilize alerting with company notifications monitoring. A shared responsibility model shall be in place. Azure. The application access protection requirements for Azure include implementing Azure WAF on application gateway, with the standard rule set available. 1269688 AWS, Introduction to the AWS GovCloud, US, Regions, https://aws.amazon.com/govcloud-us 89119 US Department of State, the International Traffic in Arms Regulations, ITAR, Directorate of Defense Trade Controls, www.pmddc.state.gov/ddtc_public ID =DDTC_KB_article_page &SYS_ID=%sign 2024D528 FDDBFC 9300444 F9 FF621 F961987 90-120 Microsoft, United Kingdom Government Cloud, G Cloud, https://docs.microsoft.com/n-us/microsoft-365/compliance Offering G-Cloud UK 91-121 AWS, cloud computing for the U.S. intelligence community, https://aws.amazon.com/federal/us-intelligence-community 92-122 Inspector General, Report on Joint Enterprise Defense Infrastructure, JEDI, Cloud Procurement, U.S. Department of Defense, April 13, 2020, https://media.defense.gov/2020/APR/2002085087/1/1/1/report %20 on %20 the %20 joint %20 enterprise %20 defense %20 infrastructure %20 JEDI, %20 cloud %20 procurement T %20 DODIG 2020-079.pdf 93-123 Google Cloud, Google. Cloud for Government, https://cloud.google.com/solutions/government 94-124 Google Cloud, Google Cloud Armor, https://cloud.google.com/armor 95-125 OPSIIT OWASP 96-126 Microsoft, what is Azure Web Application Firewall on Azure Application Gateway, September 16, 2020, https://docs.microsoft.com/n-us/azure/web application firewall/ag/ag overview 154 Certificate of Cloud Auditing Knowledge Study Guide copy. The application access protection requirements for AWS include implementing AWS WAF, with the standard rule set available. 12797 in this example, both CSPs maintain a similar product. This can principally be due to well-established enterprise products that translate effectively to the cloud. There are similar threat models and use cases identified within both providers. Encryption requirements analysis and baseline configuration. This is a requirement commonly found in policies and internal control frameworks based on legislative and international standard requirements. The purpose is to address confidentiality and availability aspects within their control implementations, example by extending the virtual disk encryption baseline configurations. Sample encryption requirements follow. All data encrypted at rest for all storage services. Keys managed in a vault backed by an HSM. Keys rotated every 90 days. Shared responsibility model in place. Azure. The encryption requirements for Azure include the following. Implement Azure Disk Encryption. 128.98 This service is integrated with Azure Key Vault. 129.99 Use Azure Security Center to monitor for alerts on VMS that are not encrypted. The encryption requirements for AWS include the following. Implement encryption on the storage volumes used by the EC2 server. EC2 server. Amazon EBS encryption is an encryption solution for EBS volumes and snapshots. 130.100 It uses AWS Key Management Service, AWS KMS, Customer Master Keys, CMKs. 131.101 Activate an AWS config 132.102 rule to check for not encrypted EC2 volumes. In the AWS example, CSP implementation differences require additional setup and per-use costs. Consumer business models and common business cases can influence product choices. Ease of use and system flexibility may push a consumer toward fewer service needs in Azure, as would legacy compliance for an all-Microsoft enterprise structure. 97-127 AWS, AWS WAF, Web Application Firewall, https://aws.amazon.com/waf 98-128 Microsoft, Azure Disk Encryption for virtual machines and virtual machine scale sets, October 15, 2019, https://docs.microsoft.com/n-us/azure/security/fundamentals/Azure Disk Encryption VMS VMSS 99-129 Microsoft Azure, Key Vault, https://azure.microsoft.com/n-us/services/key-vault 100-130 AWS, Amazon EBS Encryption, https://docs.aws.amazon.com/aws/ecc2/latest/user-guide/ebs encryption.html 101-131 AWS. Customer Master Keys, CMKs, https://docs.aws.amazon.com/kms/latest/developer-guide/concepts.html number sign master _keys 102-132 AWS, AWS config, https://aws.amazon.com/config 155 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Additional controls considerations beyond the previous simplified requirements analysis example. Specific controls implementations vary based on cloud delivery model, specific technology, or vendor construction methods. This section includes some things to examine. Delivery model considerations. Control implementations for cloud delivery model follow. IaaS consider multi-factor authentication, MFA, for an account may require a specific token vendor implementation that is incompatible or requires manual translation for use with existing cryptographic management systems. Cloud effect, complicated policy, standards, and processes may insist on enterprise key controls based on a competing technology. SafeNet Gemel to tokens 133103, Google Titan Security Keys 134104, Microsoft Oath TOTP Hardware Tokens 135 POS consider, POS database feature implementations vary from service to service. The attractiveness of POS is based on increasing resiliency and speed, or on automating difficult activities. For example, master/slave node elections may be necessary for clusters in an on-premises or IaaS deployment. POS services may build in clustering features, removing the need for election configuration. Cloud effect, use of these configurations may introduce stickiness, the idea that scripting code and feature automation may not be portable and may result in vendor lock-in. Deciding a direction should be a strategic decision, weighing ease of use versus provider dependence. Following are 3 references for Oracle as a service, Oracle Database as a Service 136106, Amazon RDS for Oracle 137107, Oracle Solutions on Microsoft 138108, SaaS consider, data loss prevention controls within enterprise storage environments utilize techniques for data at rest, data in motion and data in use. Use. These include capabilities of exact file matching, partial index data matching and pattern matching. Within a cloud environment, and particularly with SaaS providers, the shared responsibility model limits data access. Storage vendors may only provide a subset of pattern matching, such as 16-digit credit card number checks, 9-digit US Social Security numbers, or file name/list checks. 103-133 AWS, multi-factor authentication, https://aws.amazon.com/im/features/mfa 104-134 Google Cloud, Titan Security Key, https://cloud.google.com/titan-security-key 105-135 Microsoft, what authentication and verification methods are available in Azure Active Directory, https://docs.microsoft.com/n-us/azure/active-directory/authentication/concept authentication methods 106-136 Oracle Enterprise Manager Cloud Administration Guide, https://docs.oracle.com/html/e28814 Cloud effect. If previously implemented controls or processes required freeform or index matching, users may need to consider additional CSP services, instance-backed products, CASBs, or other third-party integrations. Several storage platform or storage as a service combinations, AWS S3 and Macie 139109, Google Cloud Storage and Cloud DLP 140110, Microsoft Azure Blob and Information Protection 14111, Box DLP 142112, Dropbox with Symantec DLP 143113, Scalar Cloud DLP 144114, Netscope DLP 145115. CSP feature considerations. The previous baseline configuration examples show a simplified requirements analysis, but control implementation choices may not be as straightforward within a single CSP. The volume of cryptographic choices per service varies. Examining key creation and management within IaaS environments should include the following. Consider, enterprise solutions require a key management server and client-based access capabilities for encryption. Cloud effect. Consumers could continue to use their existing key management infrastructure or stand up an IaaS key management server instance, facing most of the same control challenges. Otherwise, three basic scenarios exist with cloud encryption, all surrounding who controls the key material and where the cryptographic operation occurs. Encryption in the cloud methodologies begin with who maintains the key material. General cloud encryption options, server-side encryption, SSE, and key management is the simplest format for implementation. The CSPA handles everything. The overhead for doing anything beyond this through other services, like object storage, is unreasonable. Think of SSE as a checkmark in a CSP management console to turn on encryption. If the CSP offers a customer master key, customer managed key or bring your own key, the consumer uses its key management server for key generation. The customer loads the key into the CSP system and the CSP handles all encryption operations based on that value. The key could be exported or removed and replaced within the service. Vendor key management procedures must be reviewed for customer control acceptance. A hardware security module, HSM, has a special designation for encryption functions. 146-116 It is the most secure option, and hardest for the CSP implementation and the customer's use. Once a key goes in, it cannot be exported. It can only be replaced, even if it's with the same key after removal. Per HSM design, any attempts to remove the key will erase the device. Examples of multiple technology implementation names within a services vendor follow: AWS Key Management Service, KMS Server-Side Encryption, SSE, SSE KMS with Simple Storage Service, S3, 147.117.139 AWS, Amazon Macie, https://aws.amazon.com/Macie 110.140 Google Cloud, inspecting storage and databases for sensitive data, https://cloud.google.com/dlp/docs/inspecting-storage 111.141 Microsoft, Azure Information Protection Documentation, https://docs.microsoft.com/n-us/azure. Information protection /112-142 box, data loss prevention, www.box.com/security/data-loss-prevention 113-143 Dropbox, Symantec, www.dropbox.com/app-integrations/Symantec 114-144 Scalar, data loss prevention has become more difficult, www.zscalar.com/products/data-loss-prevention 115-145 Netscope, data loss prevention, www.netscape.com/products/capabilities/data-protection 116-146 National Institute of Standards and Technology, NIST, FIPS 140-3 Security Requirements for Cryptographic Modules, Computer Security Resource Center, CSRC, March 22, 2019, https://csrc.nist.gov/publications/details/fips/140/3/final 117-147 AWS, How Amazon Simple Storage Service, Amazon S3, uses AWS KMS, https://docs.aws.amazon.com/kms/latest/developer-guide/services-s3.html 150KMS Customer Master Key, CMK or Bring Your Own Key, 148.118 Hardware Security Module, HSM, Customer Master Key Creation 149119 Azure Key Vault, Server-Side Encryption using Service Managed Keys 150120 Server-Side Encryption using Customer Managed Keys in Azure Key Vault 151-121 Server-Side Encryption using Customer Managed Keys on Customer-Controlled Hardware, Host KMS Customer Master Key, CMK or Bring Your Own Key, 148118 Hardware Security Module, HSM, Customer Master Key Creation 149119 Azure Key Vault, Server-Side Encryption using Service Managed Keys 150120 Server-Side Encryption using Customer Managed Keys in Azure Key Vault 151 Server-Side Encryption using Customer Managed Keys on Customer-Controlled Hardware, Host Your Own Key HYOK, 152 as shown in the Delivery Model section, 2.7.3.4.1, CSP Implementations up the SPI stack. Remove options for users. 3 additional examples from Oracle, Microsoft, and CyberArk provide perspectives to reinforce the point that consumers may find another provider if the controls that a CSP chooses are unacceptable. Oracle as a service employs transparent database encryption for its POS product. Server-side implementations use 2-tiered keys for protecting the tablespace data, files, and backups. Oracle avoids CMK or HSM implementations, opting for ease of use. Oracle as a service transparent database encryption 153 while POS solutions do not require underlying IaaS building blocks. SharePoint as a service uses a wide array of other Microsoft Azure services. Although that may be seen as depriving the consumer of choice, it provides opportunities for integration beyond the server-side encryption checkbox within the offering. Microsoft 365 SharePoint as a service 154124 Cryptography as a service is an example of encryption features and adjustments within a SaaS provider that go beyond a Protect My Data checkbox. Key storage, rotation, and monitoring control options for SSE and CMK rival IaaS build-it-yourself implementations. CyberArk Privilege Access Management, PAM, as a service 125 technology considerations. Although not an exhaustive services list, the following cloud technology topics support control creation in cloud terms. Identity enterprise integration strategies consider the cloud as always on, or at least that is the intent. Integration options that insist on using existing identity services will not have the same level of broad network access. Putting a complete or partial copy into the cloud, or a separate additional directory, may avoid service interruptions stemming from the enterprise. Cloud controls must be in place to keep the copies in sync or the separate hosted directory available. Attributes and tagging look past the identity components of the enterprise. The cloud offers attribute-based access controls, ABAC, providing additional activity confirmation for privileged actions, service accounts, and data classification operations. Expect new control methods, tagging headaches, and the potential for complicated rule sets in environments such as data lakes. 148 AWS, importing key material in AWS Key Management Service, AWS KMS, https://docs.aws.amazon.com/ Federation sources. Multinational conglomerates can take a cue from the U.S. Department of Defense in setting up their own central federated identity service, such as DIRS/Rapids.156126. Very few enterprises need many of the trust controls present for a military system, but the same root of trust idea occurs. Federation works well in the cloud through tokenization, but it will break down if the supply chain becomes unavailable and tokens expire. Logging CSP reliance due to the shared responsibility model and metastructure waterline. A CSP management activity logging depends completely on the CSP capabilities and processes. The typical cloud automation mantra scripts actions in lieu of administrators. Logging thereby relies on provider maturity, confidence in maintaining multi-tenancy, preventing CSP intellectual property or trade secret data leakage, and general product goals. Forensic considerations. Cloud logging depends on utility pricing models. CSPs do not benefit financially from over-recording. Instead, they offer enhanced logs to the tenant at additional cost. Consumers should carefully consider what data are necessary for controls surrounding data retention, compliance, incident response, and chain of custody. Exiting the service. The utility model comes into play again as CSPs discuss exporting logs. Large customers of security incident and event monitoring, SIEM, as a service may find the network costs for exporting log files required for complete exit unjustifiable, and may accept the SIEM as another high-priced log repository. Storage. Variable access and resiliency. There are 2 variables in cloud storage. Moving bytes in the service frequently becomes expensive. Similar to moving to tape, having fewer accesses at a higher cost per access means less total cost. Secondly, guaranteeing that your data remains in the cloud requires more CSP equipment to account for the physical threats, mean time between failures, MTBF, and programming errors. Examples of possible adjustments: AWS S3 infrequent access 157 AWS reduced redundancy 158128, AWS Glacier 159129. Destruction methods. Data destruction requirements will change after cloud adoption. Without access below the waterline, degaussing or physical destruction are not valid options, and multi-pass wipes may prove inefficient or ineffective. Crypto shredding may be the best course of action, depending on the deployment model. Consider meta-tagging strategies for data types that may cause issues, specifically with respect to privacy and the right to be forgotten. Containers. Source provenance and pedigree. Containerization allows portability similar to automated configuration management without sacrificing the speed of vendor images. IaaS providers offer container flavors as a service, including AWS Docker, 160-130 AWS Elastic Kubernetes, 161-131 Azure Container Services, 162-132 Google Containers on Compute Engine 163133 and Google Kubernetes Engine .164.134. Typically set up as microservices, containers run others' code within a cloud customer's infrastructure. Controls should be placed in keeping with the sources and quality of the products used. 156 HRC, DIRS/Rapids/TAS Support Office, https://www.hrc.army.mil/content/DIRS-2f Rapids-2f TAS %20 Support %20 Office 157 AWS, Amazon S3 Pricing, aws.amazon.com/S3/pricing 158 AWS. 2.9 Measuring effectiveness through metrics. 2.9.1 Control effectiveness. Information security management is an ongoing process that must continuously adapt to a changing threat landscape and evolving business objectives. Monitoring, a critical component of information security, should encompass the following activities: collect and review security events, preferably before they become security incidents. Monitor the effectiveness of information security processes and governance. Periodically review risk, because vulnerabilities, likelihoods, threats, and even assets change. Monitor the effectiveness of implemented controls. Monitoring the effectiveness of implemented controls means, in practice, evaluating the effectiveness of the concrete security controls that operationalize the organization control objectives. Measuring the effectiveness of concrete security controls means that a monitoring process is in place to do the following: perform continuous testing and collect security events, system logs and other evidence related to security. Perform measurements that take the collected data as input and produce qualitative or quantitative results to assess the effectiveness of each concrete security control. Establish objectives that contrast the measured results with expected results. As a simple example, consider a technical control that requires users to pick stronger passwords by enforcing that they must be at least 8 characters long and contain at least a number, a lowercase letter, and an uppercase letter. Whether the control is in place can be tested with an automated tool that regularly attempts to create an account with a password that does not match the requirements. This test should result in an error and rejection of the created account. Another option is to measure the number of monthly password security incidents reported to the support desk. The collected numbers should indicate whether the password policy reduces the number of password-related incidents, or if operationalization of the control is effective. 2.9.2 Metrics. If you cannot measure it, you cannot improve it. 165.135 The process of collecting evidence and assessing it to obtain a quantitative or qualitative result for the purpose of evaluating the performance of an information security system is essentially the process of using security metrics. Formally speaking, as defined in ISO 19086-1, a metric is a standard for measurement that defines the rules for performing the measurement and understanding the results of a measurement. Note that security professionals sometimes use the word metric colloquially to describe measurement results, which can create confusion. A measurement is defined as a process to quantify or qualify an attribute. In this context, a security attribute is a property or characteristic of an object that can be distinguished quantitatively or qualitatively by human or automated means, according to ISO/IEC 27000. A measurement, as a process, involves the gathering of data, such as system logs, test results, configuration files, security events and sometimes the results of other measurements. These elements are often collectively referred to as 135-165, commonly attributed to Peter Drucker, 1909-2005, a widely known and influential thinker on business management. 160 Certificate of Cloud Auditing Knowledge Study Guide, Copyright 2021, Cloud Security Alliance and Ccak. All rights reserved. Evidence. ISO/IEC 27000 and many other sources refer to the result of a measurement as a measure. More recent initiatives, such as NIST SP 500-307, ISO/IEC 19086 and CSA* continuous prefer the term measurement result, because the word measure has multiple meanings in information security and is a source of confusion when it comes to metrics. Measure and measurement result should be understood as equivalent. Andrew Ccak, widely regarded as one of the top security metric experts, defines 166136 good metrics as having the following ideal characteristics. Consistently measured measurements should not involve subjective criteria. Cheap to gathering evidence and producing a measurement result should be as automated as possible. Expressed as a cardinal number or percentage, avoid qualitative labels, such as high, medium or low. Expressed using at least one unit of measure. Examples include defects, hours, and dollars. Contextually specific results are relevant, enabling decision makers to take action. These are ideal characteristics, of course, and practical metrics cannot always follow them, but they establish a good standard to target. Recent research 167137 suggests a few best practices. Avoid metrics expressing results as an average or a mean, which hides information. Prefer metrics expressing maximums or minimums. Prefer metrics expressing totals to percentages. Consider a hypothetical metric describing the average time to respond to a severe incident. Assume there are 20 incidents, and 19 are treated within 2 hours, but one is treated in 15 days. The average time to process an incident is less than 20 hours. That result might not look too bad, but it hides the 15-day delay for one particular incident. Providing the maximum time to respond might be a better indicator. A metric definition should 168-138 include at least the following: the security/privacy attributes to which it applies, a definition of the evidence needed to assess the attribute, a description of the possible ways relevant evidence may be collected, a specification of the measurement method, a process that takes evidence as input and produces a measurement result as output, the time span of the measurement, example minutes, weeks, months, the required format and applicable units of the measurement result. There are many standards for controls in the cloud, but there are few standards or best practices related to security metrics. 169139, especially 170140 in the cloud. 171141136 166 Ccak. A. Security metrics, replacing fear, uncertainty, and doubt. Addison Wesley, 2007. 137 167 EUSEC project. Deliverable D 1.4 Principles, criteria, and requirements for a multi-party recognition and continuous auditing-based certifications. June 3, 2018. https://cdn0.scrvt.com/focus. C56 A7378288FEF8CF/79 at 0 Dec 99A/D 1.4 Multiparty Recognition V1.0.PDF 138 168 IBID 139 169 NIST SP 800-55 is one exception. 140 170 in 2020. To fill this gap, CSA launched an industry working group that aims to create a catalog of security metrics for the cloud, with mappings to the CSA CCM. 141 171 NIST SP 500-307 is also an exception here. 106 2.9.3 Applying metrics. Measurements performed according to well-defined metrics enable efficient and effective governance. Auditors provide value to stakeholders through the metrics and analysis provided. Results should be verifiable, based on quantitative metrics that are repeatable and that align with prioritized goals and objectives. The collection of meaningful cloud measurement results within cloud service products is frequently accomplished through leveraging available automation and setting parameters. Both the cloud customer and the auditors need to understand how measurement results are collected, automated or manually, and optimize the value of transforming data into information that can provide the basis for taking appropriate action. Metrics-based decision-making, whether by a human or through automation, requires a structured approach to ensure the right measurement results and metrics are used to gain meaningful and actionable insights. These insights provide transparency, helping ensure cloud services are adequately secured while satisfying user requirements. A common way is to apply a goal question metric approach, figure 2.18. Two major metrics lenses exist, from a business outcome perspective, and from a technical enabling perspective. For example, improving customer satisfaction is a business perspective. A technical perspective is systems availability. Customer-focused outcome metrics are important to keep a focus on customers and outcomes. The technical enabling metrics provide other insights to help deliver on business expectations. By measuring, managing, and optimizing availability, the business can meet objectives such as customer satisfaction. Many organizations now focus on business outcome metrics. However, it is important to retain technical enabling metrics that provide the early insights for proactive action. The key message is that both business and technical perspectives are required. Having more metrics is not necessarily better. It is important to use the right metrics at the right time to take appropriate action. There are many metrics, standards, and tools that have a specific focus and value proposition. Using tools and standards that do not align with prioritized goals and objectives lead to failure. Figure 2.18 Goal Question Metric Approach Question Goal Metric Business Outcome Lens Technical Enabling Lens Step 1 Clarify Goals/Objectives Example, how can the organization reduce customer account theft? Step 2 Identify core questions that are of higher priority and value. Example, does adding two-factor authentication reduce customer account theft? Step 3 Identify and define the metrics and objectives that help address the questions. Example, authentication cost per month. Example, control, IAM 14 Strong Authentication 162 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Measurement results always require meaningful context that is provided by a well-defined metric. For example, kilograms are a good unit of measurement. 200 kilograms needs context and answers to other potential questions. What are you weighing and why? Is it the weight of an elephant? How will the information be used? Is it just meant to be educational or informational? Is it part of a calculation for lift capacity of a helicopter? Does it influence the amount of feed required? What other measures are required to provide further context and perspectives? The automated collection of measurement results based on reliable metrics enables the dynamic, proactive allocation of services, while providing the transparency and accountability to build trust. 2.9.4 Cloud Computing Metrics Context Measurement results are often collected, policies and rules set, and actions defined through setting parameters within cloud products. Measurement and metrics are one of the essential characteristics of the cloud, enabling service usage consumption models, while delivering the resiliency required to build the trust needed for cloud consumption. In cloud computing, the goals and outcomes are largely influenced by the hosting, deployment and service models. For example, an externally hosted public cloud SaaS solution has unique goals and metrics that differ from an internally hosted private cloud IaaS solution. Likewise, defining parameters varies based on these options and on the specific cloud products for which the parameters are defined. In 2017, the Cloud Security Alliance produced the report, Improving Metrics in Cyber Resiliency, 172-142, which focuses on the metrics of elapsed time to identify failure, ETIF, and elapsed time to identify threat, ETIT. The report includes cyber resilience models that evaluate the relationships of loss and recovery of functionality over time from cybersecurity incidents. The report provides a good example of focusing on just a couple of priority metrics and then performing an interesting analysis of the results provided through those metrics. Service level agreements, SLAs, are a key subject area reliant on measurement results and metrics. Some contracts and SLAs can contain security attributes that will be measured, e.g., the number of failed logins, or number of users who gained privileged access rights without invoking multi-factor authentication. ISO/IEC SC38 has several standards related to cloud computing SLAs and metrics. ISO/IEC 19086-1, 2016 Information Technology Cloud Computing Service Level Agreement, SLA, Framework Part 1, Overview and Concepts 173143. ISO/IEC 19086-2, 2018 Information Technology Cloud Computing Service Level Agreement, SLA, Framework Part 2, Metric Model 174144. Auditors need to understand the key priorities and goals with the measurement results and metrics that are most applicable to gain the perspectives needed to perform their audit activities. Auditors need to understand the source and context of the measurement results and metrics provided, so that the measurement results and metrics are used, by humans or through automation, to provide assurance and take proactive action. Tools that provide measurement results and metrics can come directly from CSPs, third-party products, existing logs or other information sources. The available metrics vary based on the competencies, processes, tools and parameters set within the tools. IaaS metrics are typically more mature and widely available. These measures are operational in nature for compute, storage and network. PaaS is typically a little less mature, dealing with development environments. Sadly, SaaS applications are frequently immature, with metrics for specific application services lacking the insights to optimize. 142-172 Cloud Security Alliance, Improving Metrics in Cyber Resiliency, August 30, 2017, https://cloudsecurityalliance.org/artifacts/improving-metrics-in-cyber resiliency /143-173 ISO/IEC 19086-1:2016 Information Technology, Cloud Computing, Service Level Agreement, SLA, Framework, Part 1, Overview and Concepts, September 2016, www.iso.org/standard/67545. HTML 144-174 ISO/IEC 19086-1:2016 Information Technology, Cloud Computing, Service Level Agreement, SLA, Framework, Part 2, Metric Model, December 2018, www.iso.org/standard/67546. HTML 163 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 163. And effectively manage cloud services. In many cases, auditors need to collect and calibrate the data to gain insights and make informed recommendations. Software measurement and metrics are significant subject areas, often with complex models and algorithms. Similarly, the analysis and definition of security parameters within complex cloud services can make it difficult to gain transparency and to govern accordingly, using available automation. See Chapter 4 for further discussion and examples related to metrics. 2.10 Cloud Security Certification, Attestation and Validation. The following sections describe the leading types of security certification, attestation and compliance validation reports. In many cases, a CSP or its customer refer to all of these as certifications. Audit professionals, known for being precise, are the first to point out that inaccuracy, because each carries a specific meaning within the respective standard. However, all of these provide a cloud customer with some level of assurance, comfort, or trust that the CSP complies with the applicable standards. 2.10.1 What is a cloud security certification? A few years ago, when the cloud computing revolution began, most organizations faced a dilemma. On the one hand, the cloud seemed to offer clear benefits regarding cost and security. On the other hand, it created uncertainty regarding compliance and trust. Since then, this dilemma has often been successfully solved through certification or attestation, based on industry-wide standardized compliance frameworks. CSPs have submitted their services to the scrutiny of the community, through self-assessment results published in public registries, such as the CSA Star Registry, and independent external auditors, giving their customers a certain degree of assurance and trust. It is not optimal for a CSP to allow customers to audit its IT operations directly. Instead, the CSP may assign an independent audit and assessment firm to certify or attest to its information security management system and controls. This section focuses on certification, which is defined as the provision by an independent body of written assurance, a certificate, that the product, service, or system in question meets specific requirements. 175.145 The current landscape for cloud security certification standards is already quite mature. There are several general security standards and cloud-specific security standards, such as ISO 27001 and 27017, and 27018, certification CSA Star certification ISO/IEC 27001 ISO/IEC 27001-2013 is the Information Technology, Security Techniques, Information Security Management Systems, Requirements 176146 standard. It specifies the requirements for establishing, implementing, maintaining and continually improving an information security management system within the context of the organization. It includes requirements for the assessment and treatment of information security risk tailored to the organization needs. An accredited certifying body issues a certification upon a successful audit against these requirements. This allows more effective implementation of a process to ensure the confidentiality, integrity, and availability of the information and information assets of an organization, minimizing the risk and likelihood of an organization being compromised. 145-175 ISO, certification, www.iso.org. ISO 27001 enables the demonstration of a commitment to comply with global best practices, proving to customers, suppliers, and stakeholders that security is paramount. The main body of the standard outlines the requirements of a system to manage information security. Annex A is a helpful list of reference control objectives and controls that includes a list of controls for improving the security of information and assets. These controls, along with others that the organization may require, are selected by assessing the risk facing the organization and the applicability of the controls to manage, treat, and mitigate those risk conditions. The combination of the controls and the management system to maintain the controls makes ISO/IEC 27001 a highly effective information security standard. The standard follows a common approach for international systems management standards, making it easy to integrate with other systems the organization might already have in place. The 7 core elements of the standard follow: context of the organization 1, leadership 2, planning 3, support 4, operation 5, performance evaluation 6, improvement 7. The information security management system formally defined by ISO/IEC 27001 uses a summary of ISO/IEC 27002 in Annex A to suggest potential information security controls. ISO/IEC 27002:2013 provides guidelines for organizational information security standards and information security management practices, including the selection, implementation, and management of controls, taking into consideration the information security risk environment of the organization. It is designed to be used by organizations to do the following: select controls during implementation of an ISMS based on ISO/IEC 27001, implement commonly accepted information security controls, develop its own information security management guidelines. However, organizations are free to select and implement other controls as they see fit. In practice, most organizations that adopt ISO/IEC 27001 also use ISO/IEC 27002 as a framework or starting point for their controls, making changes as necessary to suit their information risk treatment requirements. ISO 27001 does not mandate the use of Annex A controls. Other control frameworks can be used. Annex A often is supplemented with control objectives from more specific frameworks, such as ISO 27017, ISO 27018, ISO 27701 and CSA Star. CSA Star certification. The CSA Star certification is a rigorous third-party independent assessment of the security of a CSP. The technology-neutral certification leverages the requirements of the ISO/IEC 27001 management system standard together with the CSA Cloud Controls Matrix, a specified set of control objectives designed to measure the capability levels of the cloud service. The STAR certification is based on achieving ISO/IEC 27001 and the specified set of criteria outlined in the Cloud Controls Matrix, CCM. STAR certification evaluates the efficiency of an organization ISMS and ensures the scope, processes and objectives are fit for purpose. It helps organizations prioritize areas for improvement and leads them toward business excellence. 165 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 165. .10.2 What is a cloud security attestation? This section focuses on attestation, which is defined as the issuance of a statement that conveys assurance that the specified requirements have been evaluated and eventually fulfilled. Such an assurance does not, of itself, afford contractual or other legal guarantees. 177.147 Guarantees. 177.147 While organizations use certification to establish and certify an ISMS at the program level, an attestation is typically designed to focus specifically on a set of commitments or criteria. Attestations are almost always performed by certified public accountants, CPAs, or similar professional designations, depending on the country. Although accounting traditionally focused on financial accounting, audit, and tax, the audit of information technology has been the largest growing practice area for CPAs during the past 2 decades. University programs and even the Uniform CPA exam now recognize the critical role of IT in modern commerce and the need for CPAs to be able to audit technology controls. SOC1/SOC2/SOC3 The American Institute of CPAs uses the term service organizations to describe entities that perform services as their main business. This is contrasted with the term user organization, which uses the services. For more than 20 years, CPAs performed specialized audits of IT internal controls, targeting service organizations. During this time, a report by a CPA firm has become the standard for reporting on internal controls at a service organization, as required by the U.S. Securities and Exchange Commission, SEC, the financial services industry, and standard contractual terms with countless service organization customers. One of the main reasons for this wide adoption is that the professional standards that underpin these CPA reports provide customers with a basis for relying on the report conclusions. The objective of these system and organization control reports, SOC, is to provide customers and the auditors of those customers with assurance over the effective operation of IT controls that are designed to address IT risk to information processing. To provide the framework for CPAs to examine controls and to help management understand the related risk, the American Institute of Certified Public Accountants, ICPA, established 3 SOC reporting options, SOC1, SOC2, and SOC3 reports. While the SOC reporting based on ICPA Statement on Standard for Attestation Examinations, SSAE, 18 standard is very US-centric, the International Auditing and Assurance Standards Board, IOSB, leverages its international standard for assurance engagements, ISAE, 3000 standard, which is an assurance standard for compliance, sustainability, and outsourcing audits designed to address compliance needs beyond the U.S. borders. ISAE 3000 deals with assurance of non-financial information. SOC2 reports, in accordance with certain criteria, trust service principles/sustainability guidelines, that do not impact financial information, should be audited in accordance with the ISAE 3000 standard. Outsourced services that impact financial information of the user organization should be audited in accordance with ISAE 3402. The ISAE 3402 standard is subject to the requirements of ISAE 3000. To summarize, ISAE and SSAE standards guide auditors. The cloud provider does not comply with any of these. CPAs, or their equivalents, perform SOC reports by following these standards, based on the criteria and objectives provided in the following paragraphs. SOC1 All SOC engagements are performed in accordance with SSAE 18. A SOC1 report is based on ATC Section 320 of SSAE 18 and is titled Reporting on Examination of Controls at a Service Organization Relevant to User Entities' Internal Control over Financial Reporting. SOC1 reports focus solely on controls at a service organization that are likely to be relevant to an audit of the financial statements of a user entity. 147-177 ISO 17000. Use of a SOC1 report is restricted to existing, not potential, customers. There are 2 types of SOC1 reports. Type 1 a report on management's description of the service organization system and the suitability of the design of the controls to achieve the related control objectives included in the description as of a specified date. Type 2 a report on management's description of the service organization system and the suitability of the design and operating effectiveness of the controls to achieve the related control objectives included in the description throughout a specified period. One of the differentiating features of a SOC1 report is that it is not based on any defined criteria. The service organization, working with the user entities, i.e., customers, has to define the controls for which it is responsible that would ultimately impact the customer's controls over financial reporting. Most CSP SOC1 reports list IT general controls, such as logical access, computer operations, change control, and physical and environmental controls as applicable. Additionally, reports may include application controls for processing of financial information, computations of financial metrics and reporting. SOC1 SM reports relevant professional standards, ATC Section 320 SOC2 recognizing that customers' need for assurance extended beyond financial objectives. The ICPA, in collaboration with Canadian Institute of Chartered Accountants, CPA Canada, formulated the initial version of the Trust Services Criteria, TSC, in 2002 to assist in brokering a trust relationship between the vastly increasing IT service and data processing industry and its customers. The objective was to provide a framework for a CPA to report on the design and operating effectiveness of security, confidentiality, availability, privacy, and processing integrity controls. Unlike SOC1, SOC2 engagements use the predefined criteria in the TSC to form the subject matter of the reports. The auditors use the SSAE 18 and ISAE 3000 standards. Like a SOC1 report, either a Type 1 or Type 2 report may be issued. The report provides a description of the service organization system. A Type 2 report includes a description of the tests performed by the service auditor and the results of those tests. SOC2 reports specifically address one or more of the following 5 key system attributes, which are aligned with the commitments made to customers. Security information and systems are protected against unauthorized access, unauthorized disclosure of information, and damage to systems that can compromise the availability, integrity, confidentiality, and privacy of information or systems, and consequently affect the ability of the entity to meet its objectives. Availability information and systems are available for operation and use to meet the objectives of the entity. Processing integrity system processing is complete, valid, accurate, timely, and authorized to meet the objectives of the entity. Confidentiality information designated as confidential is protected to meet the objectives of the entity. Privacy personal information is collected, used, retained, disclosed, and disposed of appropriately to meet the objectives of the entity. The service organization selects which of the above attributes are included. The criteria from the SOC2 TSCs are mid to high level and objective based. There is no requirement for a specified number of characters in a password, or that an intrusion prevention system, IPS, be implemented. The objective-oriented criteria are matched with 167 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 167. Specific service organization commitments that are made to customers. In that respect, the auditor is not just attesting against a specific standard, but against adherence to criteria based on commitments to customers. The SOC2 report was designed with the flexibility to address criteria, such as HIPAA 178148E prescribing, NIST CSF, and other IT, security, requirements. The STAR attestation report is a SOC2 report complemented with controls from the CCM. With the rise of cloud computing, there has been a resurgence in demand for reporting by CPA firms on controls related to security, confidentiality, and availability. Large CSPs provided or are in the process of providing their customers with SOC2 reports to address the demand. SOC2 SM reports relevant professional standards, ATC Section 105 and SSA 18, and TSP Section 100, Trust Services Criteria for Security, Availability, Processing Integrity, Confidentiality, and Privacy, 2017, otherwise known as the ICPA Trust Services Criteria. The intended users of the report are management of the service organization and other specified parties who have sufficient knowledge and understanding of the following: the nature of the services the organization provides, how the service organization's system interacts with user entities, subservice organizations, and other parties' internal controls and limitations, complementary user entity controls, and how they interact with related controls at the service organization to meet the applicable trust services criteria. The applicable trust services criteria, the risk that may threaten the achievement of the applicable trust services criteria, and how controls address that risk. Unlike SOC1 reports, prospective customers can use a SOC2 report. SOC3 engagements also use the predefined criteria in the TSC that are used in SOC2 engagements. The key difference between a SOC2 report and a SOC3 report is that a SOC2 report, which is generally a restricted use report, contains management's assertion and often less detailed description of the service and the service auditor's opinion on the description of the service organization system. A SOC3 report does not include the detailed controls and results of tests of those controls. A SOC3 report is a general use report that provides only the auditor's report on whether the system achieved the trust services criteria. It contains no description of tests and results or opinion on the description of the system. SOC3 SM reports relevant professional standards, ATC Section 105 and SSA 18, and TSP Section 100, Trust Services Criteria for Security, Availability, Processing Integrity, Confidentiality, and Privacy, 2017, otherwise known as the ICPA Trust Services Criteria. Intended users of report, anyone. 148-178 Health Insurance Portability and Accountability Act 100. SOC for Cybersecurity Report. The SOC for Cybersecurity Report was developed by the ICPA to allow organizations a means to document and demonstrate the components of their cybersecurity risk management program. There are a few distinguishing factors for this type of report. SOC for cybersecurity can leverage frameworks other than the TSCs, including but not limited to ISO 27001 or NIST CSF. Unlike a Type 1 or Type 2 SOC2 report, there are no control listings. The report contains the opinion letter, management's assertion, and a description of the cybersecurity risk management program, so in that respect it may look more like a SOC3. SOC for cybersecurity reports can include controls and operation testing. CSA STAR attestation. The CSA STAR attestation is a rigorous third-party independent assessment of a CSP's security. It is based on Type 1 or Type 2 SOC attestations supplemented by the criteria in the Cloud Controls Matrix, CCM. This assessment is based on a mature attestation standard, allows for immediate adoption of the CCM as additional criteria to ICPA Trust Service Criteria, TSC, and the flexibility to update the criteria as technology and market requirements change. Does not require the use of any criteria that were not designed for or readily accepted by cloud providers. Provides for robust reporting on the CSP description of its system and controls, including a description of the service auditor's tests of controls, thereby facilitating market acceptance. Provides evaluation over time and at a point in time. BSI Criteria Catalog. C5 The Cloud Computing Compliance Criteria Catalog, C5, 179149 defines a baseline security level for cloud computing. It is used by professional CSPs, auditors, and cloud customers. The Federal Office for Information Security in Germany, BSI Germany, initially introduced C5 in 2016. The criteria catalog supports customers in selecting, controlling, and monitoring their CSPs. Nationally and internationally established standards form the foundation for the design of the C5 criteria and the requirements for proving conformity, specifically, ISAE 3000, the German audit standard, PS 860 Prüfung außerhalb der Abschlussprüfung of the Institut der Wirtschaftsprüfer, IDW, which is in line with ISAE 3000 or other national equivalents to ISAE 3000. Auditors should consider one of these standards or national equivalents as a basis for audit planning, execution, and reporting. Auditors should consider further audit standards for individual questions of audit execution and reporting. These include ISAE 3402 assurance reports on controls at a service organization, the German IDW PS 951 NF Die Prüfung der internen Kontrollsystems bei Dienstleistungsunternehmen, which is in line with ISAE 3402, or other national equivalents to ISAE 3402. Requirements for the contents of the description of the service organization's system, which is part of the audit report, were derived from these standards, cf. Section 4.4.4.1. 149-179 Federal Office for Information Security, New Release C5:2020, www.bsi.bun.de/n/topics/cloud computing/compliance_criteria_catalog/C5_new release/C5_new release_node.html::JSSIONID =CAECB9DB59BF7B1366C1 CF31366C1CF5012_SID-SID-SID-SID-SID-SID-SID-SID Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021. In addition, the Audit Standard ATC Section 105 concepts common to all attestation engagements and ATC Section 205 examination engagements of ICPA have been taken into account. These standards supplement ISAE 3402 and IDW PS 951, especially with requirements for the consideration of subservice organizations. The corresponding audit reports build the foundation for a solid risk assessment. In 2019, the criteria catalog was reworked thoroughly, adapting to new developments and increasing quality. While C5 is based on SOC2, it adds additional controls that provide information pertaining to data location, service provisioning, place of jurisdiction, existing certification, information disclosure obligations, and a full service description. Using this information, cloud customers can evaluate how regulations, i.e., data privacy, their own policies or the threat environment relate to their use of cloud services. 2.10.3 What is a cloud security authorization or validation? Positioned between certification and attestation, both of which have specific industry terms and requirements, are more purposeful security and compliance authorization and validation assessments. These include FedRAMP, Singapore Multi-Tier Cloud Security, MTCS, and PCI DSS, among others. In these cases, a trained and authorized assessor performs a security assessment and issues a report, which authorizes a cloud customer's use of a CSP in a particular context, example hosting government data or processing credit card transactions. FedRAMP FedRAMP is a U.S. federal government-wide program that provides a standardized approach to security assessment, authorization, and continuous monitoring for cloud-based services. FedRAMP uses a do once, use many times framework that intends to save costs, time, and staff, avoiding superfluous agency security assessments and process monitoring reports. The purposes of FedRAMP follow: ensure that cloud-based services have adequate information security, eliminate duplication of effort and reduce risk management costs, enable rapid and cost-effective procurement of information systems/services for federal agencies. The FedRAMP assessment process, called a security authorization, is initiated by U.S. federal agencies and CSPs using the FedRAMP requirements, which are FISMA compliant and based on the NIST 800-53 and 800-37 standards. The FedRAMP Program Management Office, PMO, was established within the General Services Administration, GSA. It is responsible for the development, management, and operational support of the FedRAMP program. Before FedRAMP, vendors were faced with different security assessment requirements for each agency, which meant they had to prepare multiple authorization packages. FedRAMP implemented standard security baselines and processes to provide both an initial authorization of a cloud service and a mechanism for that security package to be reused across the federal government. 180150 CSPs must implement the FedRAMP security requirements in their environment and hire a FedRAMP-approved third-party assessment organization, 3PAO, to perform an independent assessment to audit the cloud system and provide a security assessment package for review. There are two paths to achieve FedRAMP authorization. The first and most common is an agency authorization. An initial sponsoring agency reviews the assessment package and issues an authority to operate, ATO. The other path involves the FedRAMP Joint Authorization Board, JAB, reviewing the security assessment package based on a prioritized approach, according to the JAB prioritization criteria, and deciding whether to grant a provisional 150-180 FedRAMP, cloud service providers, https://www.fedramp.gov/cloud-service-providers 170 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 170. Authorization. Regardless of the path, federal agencies can leverage CSP authorization packages for review and shared security responsibility model implementation when granting an agency ATO, saving time and money. FedRAMP uses a shared security responsibility and risk management model that can be leveraged among agencies based on consistent security baselines. FedRAMP provides processes, artifacts and a repository that enable agencies to leverage authorizations with the following: standardized security requirements and ongoing cybersecurity for selected information system impact levels, a conformity assessment program that identifies certified independent, third-party assessments of security controls implemented by CSPs, standardized contractual language to help agencies integrate FedRAMP requirements and best practices into acquisitions. Repository of authorization packages for cloud services that can be leveraged, government-wide standardized shared security responsibility model, ongoing assessment and authorization processes for multi-tenant cloud services. The FedRAMP security authorization process has 4 distinct areas. Security assessments. Security assessments are based on the actions of 3 partners: CSP, agency CISO, or 1. JAB, and 3 PAOs. In most cases, the agency works with the CSP in starting the assessment. The CSP must hire a 3 PAO to review documentation and conduct penetration testing. Agency CISAs or the JAB reviews the package and makes the decision to grant the ATO to the CSP, or an agency may request a provisional ATO. In either case, it is up to the CSP to submit a security package that is compliant and easy to review. The review process follows the NIST 800-37 risk management framework as tailored for a shared responsibility environment. The CSP identifies the appropriate baseline, implements appropriate security controls and documents the implementation. The CSP contracts with an accredited 3 PAO to independently verify and validate its security implementations and its security assessment package. The CSP submits the package either to the agency CISO or the JAB. In the case of JAB submission, the FedRAMP office conducts the review. After documentation is completed and test results are available, the assessment is measured against the FedRAMP requirements to determine if the risk is acceptable. Agencies can grant their own ATOs. The JAB can only grant a provisional authorization. Agencies can then leverage the JAB provisional authorization as the baseline for granting their own ATO. Authority to operate, ATO. The PMO maintains a repository of FedRAMP provisional JAB and Agency 2. Authorizations and associated security assessment packages for agencies to review. Agencies can use the provisional authorizations and security assessment packages as a baseline for granting their own ATO. If necessary, agencies can add additional controls to the baseline to meet their particular security profile. FedRAMP formally authorizes cloud services through the issuance of formal JAB or agency authorization letters in lieu of a certificate. Ongoing assessment and authorization, continuous monitoring, after a system receives a FedRAMP 3. Authorization. It is probable that the security posture of the system could change over time due to changes in the hardware or software on the cloud service offering, or due to the discovery and provocation of new exploits. Ongoing assessment and authorization provide federal agencies using cloud services a method of detecting changes to the security posture of a system for the purpose of making risk-based decisions. The CSP is responsible for continuously monitoring its cloud service offering to detect changes in the security posture of the system to enable well-informed risk-based decision-making. The FedRAMP PMO has issued several documents that guide the CSP in performing continuous monitoring. 3PAO accreditation. CSPs applying for an ATO must use an accredited 3PAO to perform independent security for control assessments as required by NIST 800-37 and 800-53A. 3PAOs are accredited by the American Association of Laboratory Accreditation, A2LA, an independent nonprofit that reports to the FedRAMP PMO. The approval process requires applicants to demonstrate their technical capabilities and their independence as an assessor. The approval process follows the conformity assessment approach outlined in ISO/IEC 17020. FedRAMP maintains a list of approved 3PAOs from which CSPs can choose. 171 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description. Image for page with label 171. Multi-Tier Cloud Security, MTCS. In 2013, the Infocom Development Authority of Singapore, now known as Infocom Media Development Authority of Singapore, and the Singapore IT Standards Committee developed the Multi-Tier Cloud Security, MTCS SS 584, standard. This standard describes the relevant cloud computing security practices and controls for public cloud users, public CSPs, auditors, and certifiers. Because security risk requirements differ from user to user, this multi-tier model specifies different control measures for different levels of security requirements. MTCS seeks to address needs such as transparency of cloud users. Transparency is a way to build trust between CSPs and cloud users. With the MTCS, certified CSPs are obliged to spell out the levels of security they can offer to their users. This is done through third-party certification and a self-disclosure requirement for CSPs covering service-oriented information normally captured in SLAs. The disclosure covers areas including data retention, data sovereignty, data portability, liability, availability, business continuous planning/disaster recovery planning, BCP/DRP, and incident and problem management. MTCS SS 584 has 3 tiers of security, Tier 1 being the base level and Tier 3 being the most stringent. Tier 1 designed for non-business critical data and systems, with baseline security controls to address security risk and threats in potentially low-impact information systems using cloud services, example a website hosting public information. Tier 2 designed to address the need of most organizations running business critical data and systems through a set of more stringent security controls to address security risk and threats in potentially moderate impact information systems using cloud services to protect business and personal information, example confidential business data, email, customer relation management systems. Tier 3 designed for regulated organizations with specific requirements and more stringent security requirements, sometimes in conjunction with industry-specific regulations to supplement and address security risks and threats in high-impact information systems using cloud services, example highly confidential business data, financial records, medical records. MTCS includes 535 controls. This may change with version 2 being prepared as of June 2020. PCI DSS. The Payment Card Industry Data Security Standard, PCI DSS, is required for any entity that stores, processes, or transmits credit card data. It is overseen by the major global card brands and implemented by the PCI Security Standards Council, PCI SSC. Entities responsible for compliance with PCI DSS are categorized as merchants and service providers. Merchants accept credit card payments for goods and services provided to customers. Service providers are any organization that helps facilitate those transactions, from payment processors and gateways to cloud computing providers. Most CSPs are defined as service providers, meaning they provide some sort of hosting or other service that may be a conduit for credit card data processing. A CSP does not have to store credit card data to be in scope for PCI, it can simply transmit. Additionally, CSPs that impact the security of their customers' cardholder data environments, such as managed security service providers, also fall into scope. An accredited qualified security assessor, QSA, performs a PCI DSS assessment. There are more than 300 specific control requirements for PCI, including specifications for password controls and multi-factor authentication, among others. PCI is generally considered one of the strictest and most prescriptive standards. 170. The deliverables include a detailed report on compliance, ROC, and attestation of compliance, AOC, which are then shared with customers, banks, the card brands, or other related parties. A cloud provider is deemed validated if it meets 100% of the requirements. 2.10.4 The value and purpose of a self-attestation. CSA Star self-assessment is a due diligence process based on the CSA Best Practice Consensus Assessments Initiative Questionnaire, CAIQ, and Cloud Controls Matrix, CCM. The CSP voluntarily publishes the results of the self-assessment on the CSA Star website, 181-151, which is freely available to the public and open to all cloud providers. Cloud providers can submit 2 different types of reports to indicate their compliance with CSA best practices: the Consensus Assessments Initiative Questionnaire, CAIQ, which provides industry-accepted ways to document what security controls exist in IaaS, PaaS, and SaaS offerings. The questionnaire, CAIQ, provides a set of 310 questions a cloud consumer and cloud auditor may wish to ask of a CSP. Providers may opt to submit a completed Consensus Assessments Initiative Questionnaire. The Cloud Controls Matrix, CCM, which provides a controls framework that provides a detailed understanding of security concepts and principles aligned to the Cloud Security Alliance guidance in 13 domains. As a framework, the CSA CCM provides organizations with the necessary structure, detail, and clarity relating to information security requirements tailored to the cloud industry. Providers may choose to submit a report documenting compliance with the Cloud Controls Matrix. 2.10.5 The compliance fatigue problem. Security compliance based on third-party audit is becoming increasingly complex, especially due to the considerable number of national, international, and industry-specific standards and certification schemes present in the market. Proliferation of certification schemes. The proliferation of certification schemes is generating compliance fatigue in the industry, not to mention contradicting audit reports related to similar controls, especially for companies operating on a global scale. That often translates into substantial costs for the service providers that can afford compliance with multiple standards, potential barriers to market entry for smaller providers, and confusion for users/customers, who are not necessarily experts on certification and standards, and who might have trouble in understanding which compliance seal to rely on. The value of a multi-standard compliance and auditing program at first sight. All these new certification schemes seem to be uniquely heterogeneous, because they target wider or specific application areas, example national, sectoral, and regulatory domains and requirements, but this is not the case. Cloud-based certification schemes are based on globally accepted and widely used standards, example ISO/IEC 27001. Consequently, their very core security domains and requirements are largely homogeneous from the perspective of security requirements and objectives. As a result, many of the existing cloud security standards, especially national ones, include many overlapping requirements. It is valuable to identify common denominators between these requirements and present them under a comprehensive framework. EUSEC 182152, a European Union-funded project, conducted a study of compliance schemes. Researchers observed that many certification schemes' individual security requirements and control objectives are largely the same. Most of the 151 Cloud Security Alliance, CSA Security Trust Assurance and Risk, star, https://cloudsecurityalliance.org/star 100 requirements, 71%, were satisfactorily covered with the CCM controls, while only 29% of the requirements were covered partially, 16%, or were not covered, 13%, by CCM. Consequently, when a CSP obtains a certification or attestation under two different schemes, a lot of work is duplicated, unduly increasing costs and complexity. Therefore, it seems that in many cases, the work done under one compliance scheme should be reusable under another. This would allow CSPs to focus on the differences in security requirements between multiple compliance schemes. The mutual recognition approach would streamline the cloud compliance process, bring efficiency, increase assurance, and reduce reassessment costs. It should not be a surprise that most CSPs undergo more than one type of assessment based on the markets they are in. Another trend in the marketplace is the use of custom control frameworks. CSPs identify a standard set of controls that are common across the different compliance frameworks. To be clear, this requires work, and it is not possible to purchase or download a set of controls that guarantees compliance with everything. The CCM is a great starting point for such an initiative, but it needs to be customized and reflect the cloud provider's unique scope of services, responsibilities, and commitments to their customers. 2.11 Chapter 2 Knowledge Check Review Questions 1. What is the objective of a cloud compliance program? Select the correct answer. A. To ensure all aspects related to the cloud adoption in an organization adhere to the requirements for which it is accountable. B. To determine the risk appetite and risk tolerance of the organization. C. To drive decisions for the measures put in place by the organization. D. To validate the organization is aligned with their competition and can remain competitive. 2. What is the difference between legacy and cloud compliance programs? A. There is no difference. B. Cloud compliance relies on systems with defined boundaries. C. Legacy compliance programs have complete control and responsibility for the infrastructure and all requirements that keep it secure. D. Cloud compliance programs rely on third parties for the delivery of technology with complete control and influence over the quality, availability, and reliability of the service being provided. 3. What is a cloud governance and strategy audit? A. An audit that evaluates the framework of the organization for defining requirements, performing risk assessments, monitoring controls, reporting adherence, and developing a strategic plan for the cloud. B. An audit that covers logging, monitoring, scanning and alerting of a system, account, or environment, and can be achieved using real-time automated scripts or manual testing. C. A review of all user and service accounts, and permission within your information system boundaries, including on-premises systems, cloud environments, and other applications. D. An audit performed against technical, administrative, and/or physical controls as defined in the organization policies and procedures. 174 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. Answers on page 176. 4. Select all the correct statements concerning legal and regulatory requirements, standards, and security frameworks in the cloud. A. They serve to guide the cloud controls program of an organization. B. They should be monitored to ensure that changes in the requirements are promptly reflected in the cloud compliance program. C. They are important for when designing the cloud compliance program, but not so relevant during the execution phase. D. The majority of the laws and regulations are cloud-specific. 5. In a DevOps IT environment, the following team is responsible for mitigating and/or managing risk on a daily basis. A. Internal audit. B. Risk management. C. DevOps. D. Quality assurance. 6. Due to the shared responsibility model, control operationalization in the cloud, select all that apply. A. Is different from what it is in traditional on-premises IT environments. B. Involves a combined effort from multiple parties. C. Is simpler than control operationalization in traditional on-premises IT environments. D. Should replicate the control environment of traditional on-premises IT environments. 7. What is a common way to come up with metrics that support a decision process? A. Apply the goal, question, metric approach. B. Apply the metric, measurement, decision feedback loop. C. Make sure that this law contains automated metrics. D. Use the ISO/IEC 19086 standard. 8. What is FedRAMP? A U.S. federal government program that provides a standardized approach to security assessment of cloud-based services. B. A U.S. federal government program that provides a risk management model that can be leveraged among U.S. agencies for IT certification. C. A U.S. federal funding program that helps innovative startups in information security achieve ramping growth. D. A collaboration between ICPA and the Canadian Institute of Chartered Accountants, CPA Canada, for a federated approach to attest IANS. 175 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2020. Chapter 2. Answer key correct answers appear in bold font. 1a. Knowing what the organization is being held accountable for is critical to build the compliance program around so each objective is being met. B. Establishing the risk appetite and risk tolerance of the organization are not the objective of a cloud compliance program but important aspects when designing your cloud compliance program. C. The purpose of enterprise risk management, ERM, governance policies, the Info SEC department, data privacy, etc., is to ensure that decisions are made correctly and have a proper foundation when choosing what to do. D. This is not the objective of a cloud compliance program. 2a. The primary difference between legacy and cloud compliance programs are the control of the service being provided and responsibilities that belong to the organization. B. Legacy compliance programs rely on systems with defined boundaries. C. Cloud-based environments will follow the shared responsibility model where the cloud vendor and customer will document each party's responsibilities. In legacy environments, there is no cloud vendor and the organization will be required to maintain all aspects of the infrastructure. D. Cloud compliance programs do rely on third parties for the delivery of technology but have limited control and influence over the quality, availability, and reliability of the service being provided. 3a. This is the definition of cloud governance and strategy audit provided in the Certificate of Cloud Auditing Knowledge Study Guide. B. That's the definition of configuration and activity monitoring. C. That's the definition of access review. D. That's the definition of compliance and controls audits. 4a. Legal and regulatory requirements, standards, and security frameworks are indeed between the main driver of an organization compliance program. B. Legal and regulatory requirements, standards, and security frameworks shall be monitored to ensure alignment over time. C. Legal and regulatory requirements, standards, and security frameworks are relevant during the whole cloud compliance program lifecycle, from design to implementation. D. The majority of laws and regulations are not cloud-specific, but cloud-relevant. 5a. Internal audit is a third line of defense team that periodically validates that risk management activities are appropriate, and that controls are in place work as expected. B. Given the frequency of changes and deployments to production in a DevOps environment, the risk management function doesn't manage risk on a daily basis but checks afterwards if policies and procedures were followed. C. Given the frequency of changes and deployments to production in a DevOps environment, the DevOps team is responsible to mitigate and/or manage risk on a daily basis. D. A quality assurance team is not responsible for managing risk. 176 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 176. A. Organizations have full control of processes implemented in their traditional on-prem IT environments, while for cloud environments, the cloud service provider, CSP, manages a portion of the technology stack. B. Both the cloud service provider and cloud customer are responsible for implementing and operationalizing controls in the cloud. C. Some controls in the cloud may be simpler to implement given the tools the cloud service provider, CSP, makes available to its customers, but other controls may not be possible to implement given that the technology infrastructure in a cloud environment is shared. D. As a general rule, it's important to avoid the temptation of replicating traditional IT practices in the cloud when better cloud-native approaches exist. 7a. Correct. This is the proposed approach described in the course. B. Incorrect. This was not suggested as a correct approach. C. Incorrect. Automated metrics and measurements are great, but that does not mean they support a decision process. D. Incorrect. This standard deals with metrics, but not decision-making. 8a. As the FedRAMP website states, FedRAMP simplifies security for the digital age by providing a standardized approach to security for the cloud. B. That's not the main purpose of FedRAMP. C. No, FedRAMP is not a funding program. D. No, this is unrated to SOC 177 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 2 Cloud Compliance Program. Image with the following description, image for page with label 177. Page intentionally left blank. 178 Certificate of Cloud. Introducing CCM and CAIQ 3.1 Learning Objectives, 183.2 Overview, 183.3 The CCM and how it was created. 183.4 CCM Domains, 186.3.5 The Consensus Assessment Initiative Questionnaire, CAIQ, 2043.6 CCM and CAIQ Structure. 2093.7 CCM Relationship with Other Frameworks, Mappings and Gap Analysis, 218.3.8 Transition from CCMV 3.0.1 to CCMV 4, 225 3.9 Chapter 3 Knowledge Check, 226 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. 100